Hi, and Lucinda.
Good morning, everybody. Welcome to today's Open Day. We're really excited after almost 2 years in only being at home to have an actual physical event where you can not just view people, but actually see people, and you can see and touch real demos. So is this AI is going to be an interesting thing for the whole world, and it can be used for many things, lots of which you will see today. But one of the things is the caring about land and water, and AI is used in many places of the world already for this. With that, I would like to acknowledge the country. RMIT University acknowledges the people of the Woi Wurrung and Boon Wurrung language groups of the Eastern Kulin Nation, on whose unceded lands we are conducting the business of the university and today's meeting. RMIT University respectfully acknowledges their ancestors and elders past, present, and future. And RMIT also acknowledges the traditional owners and custodians and their ancestors on the lands and waters across Australia where we conduct our business. Not only do we acknowledge the land and the water, but we also have in today's program an interesting lunch which is going to be served by Mabu Mabu, who uses traditional native Australian ingredients in their menu. We have a very exciting program of a number of RMIT researchers showing their research, but also of industry partners showing their technology and giving you presentations. I'd also like to acknowledge our sponsors, from whom you will be hearing as well, who are sponsoring the coffee, the lunch, and the networking cocktail at the end. RMIT is a large university, and CIAIRI actually is spanning the whole of the university, and we had to make a tough choice because we can't really show you everything. So this is a great selection from technology, from engineering, but also from law and business, because AI isn't just a technology question. It is also questions about business, about how it influences the law and the ethics. So we're going to look at learning technologies, computer vision, mixed reality, agent-based decision-making, ethics of AI, and from the sponsors, we have a number of presentations which mix in with those technologies. CIAIRI is a very recent organization. We actually got founded and started just before we went into lockdown last August again. And we couldn't hold an official launch event in person, so we had that virtually. But it's really all about solving problems of businesses, real world problems. I formulated this as today's business needs, but this isn't just today as this minute. This is also what might keep you up at night about the future of your business or your industry or what's going on. So it spans a whole range of real world problems. And our mission is to really partner with industry to work on these problems, to do research which has impact on those businesses, on society, and the world we live in. And we put our focus on building tools, because humans have been tool builders forever. We always try to make things easier for us, faster, better, and so we build tools. And that's our key focus. We're not trying to build the ultimate AI machine which promises to be smarter than we are. We're happy if we can already build a tool which helps us to be better. We have here the central leadership. I have the honor of being the director of this new organization. Professor John Tangarajan is responsible for the research. Rita Arrigo is the deputy director, and Associate Professor Andy Song is the center manager. I'd like to put my thanks out to Rita and Andy. They have spent an increasing amount of time over the last couple of weeks to get this event up and running and help everybody. But I also like to thank all of you for coming, for the interest to engage with us, and please feel free during any of the breaks to talk to us if you have interest on how we can engage. One of the problems we're facing is, as Edward Wilson, an American sociobiologist, put it, the real problem of humanity is that we have a Paleolithic emotional background. We organized in medieval institutions, and we're wielding godlike technology. And in fact, as a humanity, we have been able to push technology much, much faster than we as separate humans by ourselves kind of evolved. So as a community, we were able to do a lot in this space. And it reminds me of Arthur C. Clarke's third law, which says any sufficiently advanced technology is indistinguishable from magic. And you don't actually need to fully understand the technology to use it. I mean, most of us probably couldn't build a car from scratch, but we can easily drive them. None of us probably could by themselves build a mobile phone, but we have no problems using them. So, so with that, let's look at some of the things. One of the things I'm the most afraid about AI is that it exactly does what we program it to do. There's a lot of hype out there that it will replace all our jobs and will replace us. I'm not as afraid of that. But as with the Sorcerer's apprentice who got magic to do his work, but then wasn't able to control it, there are already similar examples in AI. And this is not new. This wasn't Disney in 1940 who invented this. This was actually Goethe, a German philosopher in 1797, who wrote the basic poem of the Sorcerer's Apprentice. So we have a long history in humanity to fear new technologies. It's up to us to make sure we're using it the right way and we use it to solve problems. And we find ways to test it and to be careful as we're going forward with these kinds of things. So what are we doing in CIAIRI? We are mostly working to partner with industries. That can take many forms, from research partnerships, in a very blunt sense, research for hire, to partnering to do collaborative research jointly, to jointly participate in going after grants. And I mentioned two here, but there are many of those. Many of those require that universities and industry partner together. Two current ones in the AI space is the Next Gen graduate program, to which submission are starting now, and then announced over a year ago, but the actual specification of submission didn't come out until just 5 days ago, with one of the shortest reaction times I've ever seen. Within a month, we have to actually get together a proposal for one of the 4 national AI centers of competency. Now, let me give you a bit more details about the NextGen Grad program. The government has commissioned a study to look at skills gap in the Australian workforce, and they found that there will be 161,000 skilled talent missing by 2030 with AI and digital skills. They have a number of programs, some of which already announced, coming out, a lot more in the wings. The one right now currently underway is that NextGen graduate program. And having worked in industry before I joined RMIT, I've used a lot of similar programs to interact and collaborate with university. The best programs in the past were kind of like, I put in $1 and I get $2 worth of value out of it, because the government would put in the grant $1 as well. This program's one of the best I've ever seen. It's actually 40-60, so industry puts in 40 cents, the government puts in 60 cents to the dollars. Really great program, all about building PhDs and masters with the AI skills. And we have to build cohorts. They want cohorts of at least 10 students. So at RMIT and CIAIRI, we've picked 3 topics where we're going to focus on, but that doesn't mean other topics couldn't be entertained as well. One's around critical infrastructure, digital twins. Critical infrastructure spans everything from physical stuff like bridges to logistics, transportation, all the way to digital things like all the underlying digital infrastructure we use to run the Australian government, Australian society, etc. So it's a very wide space, and almost every business in some way, shape, or form will touch on critical infrastructure. So I think there's a lot of opportunity there. Food and waste, one of the strengths of RMIT is its food capabilities out in the Bandura campus. And for Australia, as a producer of food, which gets exported a lot, this is an important area as well. So we think that will be a good one to build. And then unfortunately, Australia, the land of floods and fire, emergency management is also a very critical part. So these are the 3 areas, but as you've seen, many of them are very wide. And to actually be part of it, you only have to pick a piece of, not the whole thing. So these are the topic we're going to look at. The artificial intelligence and digital capability centers really all focused around driving adoption of artificial intelligence in Australian businesses. And as I said, we have a very short runway to build this, but that is another good one to partner. This one has an even better payout ratio. The announcement on the 31st was that 25% of the funding has to come from industry, and the grant will put in 75%, a really significant ratio. And when I was running a research lab for IBM, every time I could make a business case where I say, I put in $1, but I get $4 worth of value. Well, I never could make that case before, but I got a lot of programs through where I could say, I put in $1, but I get $2 worth of value out of it. So feel free to talk to me about how to navigate these kinds of things, and talk to any of the researchers about your problems and things we could be doing together. So again, let me thank the people who organized this organization, Rita Arrigo and Andy Song, as well as all the researchers who put in time and effort to put these demos up to get us a really exciting day to look at these AI technologies. But let me also thank our industry sponsors who make sure that we also have some food along with thoughts. So thank you very much. And now I'd like to hand it over to Professor John Tangaraja, who will be the master of ceremonies for this morning.
I'll get you on the mic loud enough anyway. So to kick things off, the tech talk's off. We'll start our first session. If I could invite the 4 speakers, if you could come up the stage, please. So the first session is on all the rage that is in AI today, machine learning, right? We've discovered an age-old technology, but the use of it as hardware has accelerated. So no surprises there. We're going to kick off with a session on learning technologies. And one important aspect of learning technologies, of course, is how do you include the human's preferences as we get our machines to learn things. So our first speaker is Minyi, and she's going to tell us about her research on preferential reasoning.
Thank you. Oh, hi, can you hear me? Nice, okay. Well, yeah, not tall enough. All right, yeah, so very happy to give the first talk today. We are going to talk about, I think it's going to be very soft landing, preference elicitation and learning, right? What you like, what you don't like. All right, okay, so preferences. Anybody should be aware of what preferences are, right? They're basically everywhere in real life, right? So we have that, we consider user preferences to be able to recommend the best product for them, right? We're able to configure the best products for users, or if you consider applications, right? We are able to construct the user interfaces based on user preferences, or even we can customize search results based on, let's say, demographic data, user preferences data, right? So preferences are everywhere. Now, thinking about preferences, what kind of preferences did user have, right? Human have, right? If you can consider, sometimes we can give absolute judgments by saying, well, as simple as binary, you like it, you don't like it, right? Or sometimes you give a more kind of scale result, say, I like it very much, or it's just okay, right? Or even sometimes we can give a numeric ratings on the outcomes of products that we have, right? And of course, other times we can do simple comparison queries, say, I like this one over the other. Or in some applications, you might even see that they ask users to give a ranking over, let's say, a list of 5 products, right? Now, to be able to learn about user preference or elicit user preferences, we need to be able to represent them, right? And also later on, we need the computers to be able to process them, to be able to give us important insights for product configuration, for customizing search results, or for configuring our products, right? So we can consider very traditional way of representing them, like using a function, right? The very basic function here basically say, oh, well, I like dark chocolates almost twice as much as I like milk chocolates, right? Too sweet for milk chocolates. Or you can simply leave a preference order, say, I prefer one over the other. And from time to time, we can also think about logical models where you can express your conditional preferences, like my preference on my main, right? My preference on my entry or desserts in a meal probably depends on what the main is, right? So once we got the representation, we can get the computer to represent them, learn about the preferences, then what can we do from there? Right, so a lot of these product configuration, customizing search, right, so more or less it's based on 2 of the most important queries with regard to preference. One is optimization. Once you have the models about human preferences, what we can do is, how can we construct the best product? What is the best outcome for the user, right? On the other end, if we go multiple alternatives, we want to know which alternative the user prefers, right? So if we are able to do such analysis, there are lists of things that we can do. We can do decision support systems, right? We can make group decisions once we collected millions of users' preferences. How can we find an outcome that benefit most of them, right? We can do social choice and voting systems. We can then even do task allocation systems, right? With considering users' hard constraints, hard preferences, soft preferences, and of course, the other most related application that we have is recommender systems, right? Be able to understand what is important for the user, what the user like the most. We will be able to recommend the most preferred outcomes for them, right? And is that all? Probably no, I still have 6 minutes. All right, okay. So indeed, such preferences, even the most simple binary signal of whether or not you like one thing or you don't like one thing, or you like one thing over the other, can actually use to train a compressed autonomous system, sorry. Right, okay, so if you think about, this is an AI era, right? So we have machine learning, we have reinforcement learning, we have autonomous systems, we can train autonomous systems, right? They are absolutely compressed systems, and they are data-driven, right? They learn from a lot of data, and then they behave the way that they learn, right? However, is that all? Is that, you know, what we want them to do? From time to time, you will see the results are a little bit unexpected, right? So what can we do from there? That's what, when we want to design an autonomous systems, right? We have a lot of expressive preferences. We want the system to do this and do that. And sometimes we can explicitly state out that we want the system to do it that way. However, there are a lot of things that are hidden. That's what sometimes we so-called implicit preferences, right? As simple as sometimes I want their agent systems to do a couple of things. However, I want them to do it in a particular order, or I want them to do some tasks in a very fast manner. Some other tasks is less important, let's say, right? So I might also have preferences on the completion time on a particular task, right? When we have all these explicit and implicit preferences, when we design a system, it becomes very, very compressed. We can design a reward function to train the system up. However, at the end, it just leans towards the function that you design. But is that what we want? Sometimes, perhaps not, right? So then what we can do is we can actually train a very compressed autonomous systems based on beautiful, simple binary feedback from human, right? So once you get some of the results, we query the human whether or not you like it, do you like this one or that one, which outcome you prefer the best. Such simple binary preferences can be used as training signals to train autonomous systems. No matter whether you want to build an automatic text summarization system to summarize information of a long article, or whether or not you want to have you develop chatbots for business use, right? What response you consider is a reasonable or good response from the chatbot, right? So we can train dialogue systems, we can train text summarization systems, we can train agent systems, and we can train agent systems for doing planning, right? So I'm sure Julie will talk about that a little bit more in the afternoon as well. Yeah, so that pretty much aligns with the ultimate goal of human-centered AI. Right? So we want to train autonomous systems that, based on human feedback, behave the way that human expected and what they really wanted, right? And here I also want to thank DSI for the funding grant as well. So we've got the building an automatic text summarization system with limited human feedback, where we try to get the human feedback as well as putting in some data argumentation techniques there to make the learning process more efficient. I also have the previous grants requirement management framework for autonomous systems in Agile command and control as well from DSI. So on a similar topic, training, be able to elicit human preferences and train then agent systems that behave as what human expected. All right. Yeah, thanks for all. This is my talk for today. I hope we all can think about and appreciate these kind of preferences signals, simple preference signals to train compressed autonomous systems. Thank you.
In the interest of time, and since we had a bit of a late start as well, we'll save all the questions for the breaks. All the speakers will be at the breaks mingling around, so please, if you have any questions, or if you want to learn more about what they've just talked about in just 10 minutes, it's very brief, of course, please feel free to approach our speakers and have a chat with them. So talking about machine learning, deep learning, a lot of these techniques are supervised learning, as we call them. Our next speaker, Dr. Haytham Faik, is going to tell us what's beyond supervised deep learning.
Thank you, John, and thank you, Rita, Jörg, and Andy for organizing this lovely event. And today I would like to talk to you about not supervised machine learning. And so supervised learning is the most prevalent paradigm in machine learning, driving the most recent success in the field. But supervised learning requires labeled data to learn a mapping between the inputs and the outputs. For example, we've got samples here of images, and we've got the corresponding labels, and we see that these labels are precise, they are accurate, and they tell us everything we need to know to learn the mapping between the image or the data and the label. And so labeled data sets are unfortunately very difficult and very expensive to curate for some tasks at a large scale. In the academic setting, we take that for granted, but in practice, these are very difficult and expensive to curate. And so we turn our attention to unsupervised learning, where the aim is to learn of data that is not labeled. Now we see supervised learning versus unsupervised learning, but the truth is there's a spectrum in between both supervised learning and unsupervised learning, in that there are learning paradigms that learn despite limitations in the data, such that few-shot learning, weakly supervised learning, self-supervised learning, and so on. So to give you an example today, I'd like to focus the rest of this on weakly supervised learning. And so weakly supervised learning can learn from noisy, limited, or imprecise labeled data. For example, we have a recording here on the screen of a speech utterance and the corresponding label, "The cat sat on the mat." Now we note that the utterance tells us the words or the sentence that has been uttered in this recording, but it does not provide any temporal information or any alignment between the words, the letters or phonemes that have been uttered in this recording. So we know what words have been spoken, but we don't know when were they spoken. Such as an example of a weakly labeled data point. And so weakly labeled data sets can be much easier and much cheaper to curate for some tasks, particularly compared to labeled data sets. You can imagine that if we try and align each letter or each phoneme in this sentence to this recording, it would take 4 or 5 times the labeling and annotation effort, which translates to human time, which translates to annotation cost. And so to give you an example of weakly supervised learning, in practice, we applied weakly supervised learning to large-scale audiovisual sound event detection, and that was from weakly labeled data. So the task of large-scale audiovisual sound event detection is to recognize sound events from videos in the wild, so no restrictions whatsoever. The data set is weakly labeled, as the labels of each video clip denote the absence or presence of the sound event, but the clip, in the clip, but do not contain any temporal information. So for example, we have here a video of someone driving a motorbike from their point of view, and the labels of this data point is simply motorcycle, motor vehicle, and horn. We don't have the order in which they occurred. We don't have any temporal information or time information as to when these labels happened. And we applied this to a very large scale data set. In fact, this was the largest data set in the world at the time, comprising of more than 1 million samples, and each of them were labeled with more than 2 labels. So on average, there was 2.7 labels per sample. Weakly supervised learning and similar paradigms do not offer any or do not impose any restrictions on the data or models that we use. And so in this case, we used a standard convolutional neural network, rather 2 convolutional neural networks, one for the audio and one for the visual stream, and we combined them using an attention mechanism to combine both the audio and visual mechanisms. Now, the trick in weakly supervised learning is to use an appropriate loss function. And for those of you interested, the loss function for weakly supervised learning in this case was a binary cross-entropy loss function that can be trained to detect the absence or presence of each class independently, and that is independent of other labels. If we look at some results, and I'll show you some examples in a second, the model that we've proposed compared very favorably with state-of-the-art methods at the time. When we look at the mean average precision and the mean average, the mean area under the curve, where the higher is the better, and that's compared to state-of-the-art at the time from leading labs. The most important thing and the most interesting to me in this particular piece of work is that despite that the model was trained with no temporal information, with no order of the labels whatsoever, it has learned from the labels or from the data the correspondence between the labels or the sound events and the audio recording. So if we take a look, for example, at the top left spectrogram on the screen, so this is a time frequency representation of the audio recording. On the x-axis, the time in seconds, and overlaid on top of that is the probability of the classes which are in the legend above. So high means or 1 means the model has high confidence that this class is present, and 0 means the model has high confidence that this class is absent. And so we kind of see the spectrogram, the first 1/3 is a heart murmur. You probably need to hear it, but we could see that it's a low frequency audio. And so you can see that the model is indeed recognizing with very high confidence that the first 1/3 of the spectrogram is corresponding to a heart sound, whereas speech starts to take off after the first 1/3, and then the model has with high confidence that there is, or recognize that there is speech in the recording. Again, there was no temporal information whatsoever provided to the model when it was trained, and it was trained on weakly labeled data. So to conclude, not supervised learning, including continual learning, few-shot learning, meta-learning, weakly supervised learning, contrastive learning, self-supervised learning, and zero-shot learning are all learning paradigms that can provide means to sidestep the difficulty and cost of large labeled data sets for deep learning and learn from weakly labeled data despite limitations in the data. And this is essentially my research interest. This is that spectrum between supervised learning and unsupervised learning that can learn from limited data. These are the 2 references that I referred to in this work on weakly supervised learning, if you're interested in more details. And thank you very much. I'm happy to take questions afterwards.
So machine learning is great. Often it's seen as a black box, though, as if you work in the area, you know one of the biggest issues with machine learning techniques is how do you test these things? Often you need lots of data to actually set aside to actually do the testing phase when you implement machine learning algorithms. And our next speaker, Dr. Hang Ha, is going to talk about data efficient ways of testing these ML algorithms.
Good morning, everyone. My name is Hương Ha. So I'm currently a lecturer at the Artificial Intelligence discipline, School of Computing Technology, RMIT. So today I will give a presentation on data efficient active testing of machine learning algorithms. So basically, as we all know that, like currently, machine learning is employed across important sectors, from manufacturing to business, health, defense, etc. So a survey from Tortoise Media showed that the current global investment in artificial intelligence or machine learning has jumped to a record high, which is around like $80 billion in 2021, which is double the amount of investment in 2020 and the previous year. And actually in Australia, the national pool response from the IUS has shown that 82% of Australian organizations are interested in machine learning or artificial intelligence, and 54 of them actually have started to adopt machine learning and artificial intelligence in their organization. But there is always a catch. Machine learning systems actually can be unreliable. There is no guarantee that a machine learning system which has an impressive performance during the development process can still perform very well in practice. Actually, like an example is that in 2020, it had been widely reported that a Google medical AI system, which had a super performance during the development process in the lab, actually failed terribly in practice when deployed in real life. The system actually have an accuracy of like nearly 90% at a human specific level in the lab, but then when it deployed in practice, it failed terribly and it has to be retrusted within like only few months after the deployment. Another example is when the COVID-19 pandemic started. It's also like widely reported that a lot of like machine learning system from like online grocery delivery to weather forecast, banking, trading, they fail like they encounter numerous failures, despite the fact that all of these systems has performed very well pre the pandemic period. So one of the main reasons of these particular failures is that machine learning system generally require the training data distribution need to be the same, exactly the same as the deployment data distribution. But in practice, this assumption does not always hold. So I show here one example. So if you look at the image here on the left side, the training data, and the training data consists of only like image of the real cat. But on the other hand, the test data in this case, it only consists of the image of the cartoon cat. So this equals like different trend and deployment data distribution. And this will call the machine learning system who was trained on a different data distribution will fail when like deployed in another data distribution. So I use a very extreme example here, but this scenario can actually happen a lot in practice. The Google medical AI like failure that I showed in the previous slide, it actually failed because of this issue. It turned out that like the image in the deployment hospital is very different compared to the image in the Google lab. The quality is much worse, and that's why the Google medical AI system, it failed when like it actually used in real world hospital. Another issue is called like trend and test data distribution shift. And this issue is because the fact that the world always change, everything change, nothing gonna stay the same. So even at the beginning, the trend data distribution is the same as the deployment data distribution, but from time, the deployment data distribution is gonna shift from the trend data distribution. And that's called like the machine learning system who was trained on the original training data is gonna perform badly in the deployment error. So all of the issue prompt the question that in practice, the machine learning or the artificial intelligence system need to be re-evaluated constantly in order to ensure its accuracy, because otherwise it might like cause server unintended consequence. So in practice, like to evaluate the performance of machine learning or AI algorithms, normally we have to collect a lot of label data from the deployment error, and then we evaluate the performance of the machine learning or the AI algorithms using this data. But in practice, if you need to re-evaluate the performance of machine learning system multiple times and constantly, the process can be really time consuming and very costly. So motivated by this particular issue, in our work, we aim to develop a new methodology to test or evaluate the performance of machine learning system using only a limited number of label data from the deployment error. So our methods is called like data efficient active testing of machine learning algorithms. So testing means that we evaluate various metrics performance of the machine learning system to check the diversion between the machine learning system decision and the correct decision. Active means that we actively sample the data points in a smart way so that we only need to use a very limited number of label data points in order to evaluate the performance of the machine learning system. So that is called like active testing of machine learning algorithms. So basically, the input to our system is the machine learning system that we want to test the various metrics of interest. So for example, like accuracy, precision, recall, or any like bias or fairness metrics. We also require some data from the deployment error, but the data can be unlabeled. The output of our framework is the estimation of the metrics of interest. And then basically our proposed framework, we first try to get some small amount of label data from the unlabeled test data set. And then we will train a surrogate model using this label data. And then we will use our device metric-aware sampling strategy in order to select the most interesting or meaningful data point so as to send to a human annotator to label the data, and then like we will append it to the label data set. So on the process is conducted iteratively until the labeling budget is finished, and then like we can like give an estimation of the metrics of interest based on the surrogate model. So this is our proposed framework. So we have published our work in two venues. So the first one is in the CIAIRI Conference on Artificial Intelligence 2021, which is a flagship conference in machine learning or in AI in general. The other work is published in the Robust Machine Learning Workshop at ICLR 2021, and we are currently expanding this work to a journal. We also like expand our work to make it to become a general framework for online monitoring of machine learning system, and also we develop new methodology to recorrect the machine learning performance when we detect any particular performance issue of the machine learning system. So that's all for my presentation today. Thank you for your attention.
Thanks, Ang. It's certainly a very important area because testing is what builds trust. And as we know, one big barrier to entry for AI into most industries today is indeed trust. And testing is one very important part, not just in machine learning algorithms, but all AI algorithms in general. Speaking of AI algorithms and use of AI, our next speaker, Associate Professor Jeffrey Chan, he is our in-house expert in everything recommendation, prediction, and predictive analytics. But today he's going to take a slightly different angle on it, and he's going to give us a talk on his recent work on AI in prescriptive analytics. Over to you, Jeff.
Okay. Hi everyone. So I'm Jeffrey, and I want to thank everybody for the opportunity to speak to you, and particularly Jörg, Rita, Andy, and Joe for organizing the event. So today I'm just going to give a very high-level overview of some of the work we've done in the last few years in terms of prescriptive analytics, and I'll quickly introduce what that is in a little while. Before I do that, I just want to quickly give acknowledgement of country, and Jörg did a great job before that. So I just want to quickly acknowledge the peoples of the Wurrung and Burrung language groups of the Eastern Kulin nations, where we all gather and meet here today. I want to respectfully acknowledge the ancestors and elders past and present. Okay, so I know some of you probably know what is prescriptive analytics, but just, you know, so we're on the same page, I want to quickly talk about and give you a comparison of the different types of analytics that there is. So generally, there's three different types of analytics: descriptive, prescriptive, and predictive analytics. So on the far left is essentially descriptive analytics. So this is usually asking a question of what has happened. So you may have some data and you want to find out, how your sales were for the last month. What was how's everything going? And typically you might produce a dashboard to show what's going on and ask, okay, this is our actual performance. Then you have predictive analytics where instead of saying, okay, what has happened, now I should want to figure out, forecast what might happen, to my sales, for example, right, in the coming month. And then finally, there's prescriptive analytics, right, which is where we take the outputs of the predictive analytics and say, look, this is a forecast sales for my future month. And what we're going to do about it, if the sales looks like it's going to decrease, what strategy can we employ, right? And can we do that with a data-driven type of approach, right, in terms of the recommendations, in terms of what to do. Okay, so we today we're focusing on the last part. As John said, I've done other stuff also, but today we just focus on the last part and some of the cutting edge stuff that we've been doing in that space. Before I do that, I just want to quickly talk about how the conventional prescriptive analytics pipeline is to give you a sense of what's been done now and the stuff that we have done to advance that. So typically you have some data that you collected, and you might do some descriptive analytics, but then you also might do some predictive analytics in terms of forecasting in the future, right? So using an example of, say, you're running a data center, and you want to predict the demand of your your clients, right, and how much your clients will use these cloud services, right? And in that space, you might use, say, machine learning or forecasting to do that. So these are just some examples, right? So it's not representative of all the possibilities that you could do for the different type of analytics. Then you might take that and you say, look, I actually want to figure out for this cloud center, how much machines should I deploy, how much machines should I turn on, right? For, say, the next week, right? So that I want to maximize my reliability, right? For example. And now we're touching, into prescriptive analytics, and some typical methods might be decision making, and this could be both in terms of optimization, and my colleagues will talk a little bit more about agents and planning, which is another type of decision making process, right? That you could use. It could be recommended systems, could be a lot of different things that suggest what to do. And then finally, if the problem itself has multiple objectives and multiple criteria, which is the graph on the right I'm trying to show. And in the machine provisioning cloud management example was been talking about, that could be, say, reliability of the service versus efficiency in terms of, say, energy, right? So and those different points on the red line is different solution points, right? So the one right at the bottom to the next to the one in the reliability, that would be maximum reliability, but you might turn a lot of machines, so it's not very efficient. Conversely, the solution right next to the one in the efficiency, you might turn on just one machine, so it's super efficient in terms of energy usage because you're not using much energy machines there, right? But it's not super reliable because if that machine breaks, then you lose or everything essentially, right? And won't be reliable. Okay, so next, I'm going to talk about three things that we've done, and I'm just going to go through a very high level, so bear with me while we go through that. So the first one is one of the issues with this conventional prescriptive analytics pipeline is that the predictive part and the prescriptive part are done individually. So what I mean is for example, the going back to the machine provisioning example that I talked about before. For example, if we're predicting across a week of, trying to provision a week in ahead, right? The predictive part might, estimate the demand across that week, right? But because it's not aware of, ultimately the decision is basically what machines to turn on and off, right? So it's just predicting the demand. And you might have constraints, for example, like that. That on the weekends, your maintenance teams your technical maintenance teams are not quite available, right? And so you might want to turn on more machines during the weekend, right? But because the predictive part is not aware of that, so it might will make a prediction saying, look, in terms of demand, I'm just going to equally give my focus on every day and try to equally predict as well, when in fact you probably want to focus a little more on the demand prediction, get as accurate as possible on the weekend so that you provision the right amount of people, because it costs you more money also and there's less teams available. Okay, so what we've done there is we worked on this new area called Predict Plus Optimize, where we try to combine both the predictive part and the optimization part, and there's a feedback loop now. So basically, the predictive part is aware of what the actual final output is in terms of prescriptive, right? And that way it can focus its necessary attention on trying to minimize the error, the prediction, such that we'll get the best output in terms of the predictive prescriptive part, sorry. Okay, so the second thing we looked at is this area called learn to optimize, where one of the issues with currently decision making, optimization, etc., is it still requires a lot of expert knowledge in, for example, choosing which is the right solver to use and what are the right parameters to use, etc. Right, and what we've done in learning to optimize is trying to devise essentially what's a meta learning, right? So trying to learn how to optimize and come up with a black box optimization approach. And then finally, we, along with Minnie and Juan, we've been working on this interactive multi-objective optimization, right? So one of the issues with when you're optimizing multiple objectives, you have a lot of potential solutions, and the users may not know which one is the best for that. Okay, and so we kind of found a way to interactively suggest which one's the best for that. Okay, so I'm just going to show you some examples quickly, right? So I've just noticed the clock is ticking down. So in the predictive plus optimized space, we looked at a few examples. So one of these is in itinerary recommendation. And so so imagine you're going to a city and this is a map of London, right? And you want a system, a recommended system to suggest what places to visit, but also the order of them to visit, right? And so this would take into consideration of trying to predict what the user wants, but also trying to predict for example, the traffic, right? And potentially the queues, right, at these places, right? So that you maximize the amount of time you actually spend at these places and places that you want to. Another one that we looked at is energy generation. So in this case, we want to figure out which generators to turn on, right, for the next day, and given the information of the weather forecast and previous demands, right. So we predicted demand, and then schedule the generators in terms of on and off. And I'm going to skip the last one. Sorry. Okay, so can I go back, John, this way? Sorry. Apologies. So just skip the last one because in interest of time. Okay. So in the second space, this is essentially a black box learning, right? So we're trying to learn a solver. So LTO is learning to optimize solver. So just to give you the flavor of what's going on there, right? So in the typical machine learning example, which for example, Haven talked about, you'll have an instance and a label, right? But in this case, instead of a label, right, we have a solution. So optimization solution. So instance of a optimization problem and a solution to that. And so for example, in this case, we might be solving the traveling salesman problem. So think about this problem is, so your Australia Post, you got some number of parcels to deliver to a number of customers, but you want to find the route that's the shortest, right? And you need to visit all the customers. And so the instance will be all the different customer locations and the starting location of the van, and then the output will be an actual tour, right? And this is what we've done there. And the final area, just very quickly, goes over time. So in the interactive multi-objective optimization, we want to guide the solver to the best trade-off between all the objectives that the user most prefers. And so for example, we might give them two solutions and they have to pick one. So one solution is the top one is more reliable and less efficient, and the second one is more efficient and reliable. And depending on which one you pick, then we can kind of find out are the user more favoring towards reliability or more favoring towards efficiency. And I'll skip that because we're running a bit short on time. So quickly in conclusion, there's a lot of different applications that you can apply prescriptive analytics to, and I talked about 3 of those that we've been working on in terms of the approach. So predictive plus optimize, learn to optimize, and interactive multi-objective optimization. So thank you, and I'm happy to chat afterwards.
Can we also thank all the speakers again for their contributions today? Thanks, guys. So the next is a industry talk. So you can stay here if you like and get the same attention. No, exactly. So I think you'd all agree that when we come to an event like this, and I look across, most of you are coffee snobs, right? Like me, I'm a coffee snob, and I appreciate the freshly ground coffee that you can get at these events. And that's made possible today by our industry sponsor, LivePerson, so thank you. And so we have a tech talk from our industry sponsor, Harm Ellens. Unfortunately, Harm can't be here today because he has got to isolate. We still live in those times, we're still not out of COVID. But he is going to dial in, I understand, and hopefully the tech works. If not, we have a long coffee break. So I'm going to, and he's going to talk about an area I think that is the next big thing in a way in the next 5 years. Is going to accelerate and it's going to see rapid growth. An area that a lot of us, especially at RMIT, are interested in is conversational AI. We are not quite there yet, but they're making leaps and bounds. But I reckon in 5 years, and Harm will tell us a lot more about it. And his talk is on building bots with empathy. So I'll switch over and let Harm take over. Can hear me, you're good to go. And you're on mute, Harm. You're on mute.
Okay, I think we are good to go. Thank you, everyone. I'm getting a little bit of feedback on my microphone. Bear with me for 1 second. So today we're going to briefly talk about building bots with empathy. And the reason why we have been invited to prepare a presentation here is due to the fact that we have been working with many of the providers of the conversational channels like WhatsApp and Apple, WeChat and Facebook to make these conversations to happen. Bear with me for 1 second, I have to change something. So So our job is to make life easier for consumers and brands to communicate through trusted conversational AI. And we do this for a large number of organizations in this region, not just in Australia, but also in New Zealand, in Indonesia, in the Philippines, in Singapore, and in Japan. And we do this on a very large scale. We have more than 1 billion interactions flowing through our system every month. And interestingly, nearly 70% of those involve some form of automation. Now, these are interactions that flow between consumers and brands. And as a consequence, we have learned a lot over the years on what works, what doesn't work, and what makes organizations that deploy this successful. But the reality is that there are plenty of automation and conversational automations out there that are less than optimal. And of course, we all have a negative bias, a negativity bias that helps us remember some of these poorer experience. But what I'm going to share with you in the next couple of minutes is to show you some techniques on how to prevent such poor experiences from happening. But some of the sort of fundamental solutions from that lie at the heart of all of this is that sort of bricks and mortar thinking is still very prevalent inside many of the organizations that we deal with, despite the fact that they really are on a mission to digitally transform themselves. There are still many processes that require people to phone in, to visit the branch, to mail in a piece of paper, or sometimes still even having to fax some form of proof of documentation. And of course, there are still technical limitations, and these technical limitations make organizations focus on overcoming the technical barriers rather than the people that these technologies are meant to service. One of the other key challenges that many organizations face when they deploy chatbots is the unavailability of a way to continue the conversations, which is quite different from what you might experience when you message on Facebook or what have you. Conversational AI, on the other hand, is really focused on providing that continuous experience that you have in your personal life on a day-to-day basis. And the final consideration is that many of the chatbots are designed for desktop websites and not for mobiles. And when the reality is that most conversational AI occurs on mobile devices. So there is a long list of things that these constraints result in, and unfortunately you will experience these on a regular basis. But as you'll see shortly, there are actually progressive organizations that have managed to overcome these challenges. And what you see here is not a real world example. We'll get to them in a moment, but this is what is possible today to have that conversational AI experience, leveraging the best of the available technologies, both from a presentation point of view, as well as an ability to effectively use various forms of AI to drive an outcome that is what we call curiously human. In other words, as Jürgen mentioned in his introduction, an experience that's almost indistinguishable from magic. And we use a wide variety of technologies to make an experience like that possible. And I'd like to share with you over the next couple of slides the three pillars for building empathetic bots. Now, the title of this talk is deliberately ambiguous, right? It talks about the building with empathy, and that has two aspects to it. First of all, we'd like to have the end users have an empathetic experience. But as it turns out, it's actually not possible to build an empathetic experience without actually putting an empathetic process in place, managed by empathetic people who can then build empathetic systems. So top to bottom and deliberately structured that way, the three pillars of building empathetic bots start with selecting a multidisciplinary team. That means finding representatives from across your organization and from across your end user base to engage those teams in building customer journey maps, so you understand what the end users are going through. And increasingly, there's emphasis on making sure that whoever is on the other end of the conversation has a good experience as well. There's plenty of evidence that shows that a good employee experience is essential to deliver a good customer experience. As far as process is concerned, it's really important to take outside inspiration when you design the flow of your end-to-end experience, not necessarily the component that includes conversational AI, but what happens before that conversation starts and what happens once that conversation finishes. I often ask teams that I work with to share with me a memorable customer experience. And it is interesting that about 50% of people choose a negative experience when I ask the question, and the other one gives me a positive experience. Both are very, very useful to start thinking about what a good experience could look like and what we should avoid in the development of our conversation. The next step is anticipate the expected, and I have an example of that in a second. You know the process that the end user goes through probably better than the end user itself, and use that understanding. Make sure that you can measure the perception of what you are delivering in your conversational AI, and use that insight to manage the improvements. Dr. Ha talked about the continuous need to improve the solution. Nowhere is that more true than in conversational AI. When it comes to your systems, maximize your span of control. In other words, work within the constraints and try to optimize that. Layer your solution, so don't try and solve for everything. There are plenty of integratable components available today that help you do a subset of the task that you are going to do. And then think big, start small, and control growth. And in the next couple of slides, I'm going to share you some of the more empathetic results that we have been able to deliver. The first example is for Healthserve in Singapore. This was a solution that was specifically developed for immigrants who were affected by COVID in the early stages of the pandemic in the dormitories in that city, and it was particularly difficult to reach the communities that had language other than English. And there were insufficient professional health staff available to provide that information over the telephone. Instead, we worked with the Healthserve organization to build this WhatsApp-based tool to provide information other than English to that particularly affected group. Another example is a special management bot that we have deployed for Telstra. It looks at every single conversation that flows through our system, be it originated from the web or from the Telstra app or through some of the other channels that it supports. And it looks for certain word patterns that may indicate that a customer is distressed or is in a vulnerable situation financially or mentally or otherwise. And that conversation is then seamlessly transferred to a group of individuals that is specifically trained to handle those situations. Telstra has about 4,500 agents using our conversational AI platform, and not everybody is capable of handling those situations. So we have automated the process of detecting these customers that are in a vulnerable position and help them achieve that outcome that everybody wants, which is to keep people safe and to keep people in a position where they continue to use the services that Telstra provides. Another example is Open Universities Australia. It anticipated the expected. Open Universities Australia has thousands of students that enroll for its courses on an annual basis, and it knows in the first semester, for the first 12 weeks, these students will encounter various challenges as they get up to speed with starting to use the services that the Open University provides. So it has a study buddy bot that proactively, in this case via Facebook Messenger, reaches out to these newly enrolled students and helps them overcome the challenges that they are likely to face in week 1, week 2, week 3, week 4, week 5, week 6. It reaches out every week with slightly different information, checks in on whether they are feeling good or a bit anxious, and then provide resources where the students can sort of address these issues, or if they want to speak to a human being, they can. The essence of our conversational AI platform really is to make sure that a human being is available at every turn. Finally, Bupa, it is Australia's second largest health insurance fund, and they have implemented a number of conversational AI solutions. The most interesting one is one where, since customers have for a long time been in the habit of ringing the organization on their landline call center number, the IVR gives these callers the option to transition their conversation into a WhatsApp messaging one, and 70% of those that are offered that particular option do accept that. Again, Bupa understood that the customers actually had a great desire to have these conversations in a digital environment, and it helps them transition. So in order to make all of this happen, just a short plug for the tools that we make available to understand and act on customer intent, to provide that continuous improvement to the processes. The same applies for the building of our bots. If you can draw a flow diagram in Visio or another tool, you can use these tools, and we actively involve the people that handle these conversations on a day-to-day basis in the development and the optimization of these tools. And then when a human is required in the loop, we have special tools available to make that all available. And finally, if you are interested in learning a little bit more about conversational AI, in the next fortnight, a conversational design course will be available on Skills Finder, which is a course that's usually delivered through the Live Person Institute. You can get your handle on the elements that make up a conversational AI solution. And with that, nearly at time, I will encourage you to reach out to my colleagues whom you will find at the coffee cart, and maybe you can help them or other experts in the room solve this particular machine learning problem. Thank you very much for your time.
Let's thank I'm not sure if you can hear me. I think you can see me from somewhere here if I'm looking somewhere in that direction. Thanks for the talk. I'm sorry you couldn't make it here, but I really hope we can meet in person sometime soon, and also look at ways that we can collaborate as well, because it's a very interesting space, and I'm sure many industries here as well would love to collaborate with your team at Live Person. So thank you again. And on that note, we will have a coffee break. I just want to make a couple of quick announcements though, just before we do that. At that table just behind you where there's water, there's also some name tags in case you want to identify yourself a bit, make it a bit easier. Just, you know, who you are, where you're from, might be easy to break the ice and have some conversations. And also behind there, just behind those poster boards, there are posters and also some demos, and there are some demos outside as well from academics as well as some industry sponsors as well. So I encourage you to mingle, meet. We'll be back in 20 minutes for our next session. Thanks.
That was quite a nice talk. Can you hear me? It was a good talk. Very interested in those topics. Sorry, I can't hear. You can hear me? Look. Well, I'm glad the technology is going to work from home. I can hear you.
It takes about 15 seconds before it unmutes.
Ah, yeah, I'm always a bit nervous about Teams on my computer. But the first time I spoke, the whole software just collapsed. A few minutes ago, I said, at the end of your talk, I attempted to say hi because everyone else left, and all my software just collapsed. I went, oh boy, I hope that doesn't happen during my talk.
I had terrible echo whilst I was presenting.
How's my sound coming through now?
It's perfectly good.
Okay, that's good. I was intending to be on site, but I got an ISO notice, as is why.
Yes, my wife tested positive on Sunday.
Yeah, I tested positive on Monday. I have absolutely no idea by what mechanism, but I'm hearing it everywhere. The good news is the vaccinations work because I feel completely fine.
Yes.
I hope your wife's okay.
She's just woken up after a good night's sleep.
Hello, Adrian, can you hear me?
Yes, I can.
Hi, just to let you know, everybody on the live is able to hear what you guys are talking about.
Oh, okay.
Yeah.
Oh, sorry. That's right.
We will be back soon. They're still just milling around, so hang tight.
Okay, Doris. It's certainly interesting times.
Indeed.
But I think there's a new appreciation for how fantastic our medical researchers are. I'm certainly very appreciative of the vaccines they created in a very short time. And I believe computer modeling was a big part of the solution.
It was, and the ability to run endless tests and variations.
Yeah.
Everybody that I've spoken to wants to learn about what you've researched.
That's good. I'm very much still learning from the bees myself. Every time we ask them a new question, we get a wonderful surprise. And actually, Carl von Frisch, who I'll briefly mention, he wrote an influential section of one of his papers where he described bees as a magic well. So every time you every time you put your hand in, try and find out something new, you find out 10 things, and it's quite an amazing system.
It's a wonderful world of discovery.
Yeah, so I'm lucky to work with some very good artificial intelligence people to try and see how we bridge between biology and.
Okay, I'm going to go back on mute.
Okay.
Because I have a noisy cat in the background.
Anyway, thank you for your talk.
Hopefully we can do this in future in person.
I look forward to that. So I can see an organizer flicking through my slides. Can you hear me?
Yes, we can.
So am I going to, so you've got a copy of my slides there. I have a terribly old computer at home, so it might be better for bandwidth if we just run them your side and I just say next slide. Is that okay?
That works.
Okay, so we'll just, so there's only 10 slides, so I'll just say next slide. Okay, that's going to be very easy then.
No problem. That's okay.
I think you have my mobile phone number in case there's any dropout issue. Is that correct? Oh, God, it'll all work.
Okay, so perhaps we'll roll back in. It's incredible coming back after COVID, coming back in person. One of the best things is chat, and I'm going to be the Grinch and stop your chat. If you can come back in, we got. I'll just get everyone back in. Thank you. It's great. I feel bad almost because the whole point is to mingle and chat as well. So. Alrighty, so maybe we'll get started. We'll start our second session. I hope you all enjoyed your coffees. So in the next session, unfortunately, I've just got news that COVID strikes again, and our next two speakers also had to be in isolation. And you know, in the world before COVID, they wouldn't get the opportunity to speak. But then that said, if it wasn't for COVID, they'd be here anyway. But so I don't know. But they're lucky enough to get them dialing in. They'd love to be here in person, but unfortunately they can't. But the talks are very interesting talks. The first one is from Professor Adrian Dyer. And the theme here is computer vision. So this is AI lessons from the brain of the bee. So Adrian, I don't know if you can hear me or see me, but we're going to switch over to you now. So over to you.
Okay, thank you very much for the invite to come and speak, and we're certainly lucky with the technology to be able to share our information. Okay, so the bee brain has been something I've been interested in for over 20 years, and we've learned a lot every time we do an experiment. And in the past decade, we've been collaborating a lot with computer scientists to develop very novel AI solutions. Where I'll end up the talk is actually, I saw a great talk by researchers at IBM, and they were very interested in what's the future of computing because of the amount of energy we use. And the thing about the bee brain is they're solving extremely complex problems with a minuscule amount of energy. So it means there's some bio-inspired solutions we can think about. So the bee brain has less than about 1 million neurons, but it has a very structured organization and shows evidence of both parallel and serial processing. It can solve extremely complex problems, which I'm going to walk you through a few examples in a minute. So it's a classic deep learner. Can we go to the next slide, please? We know a lot of this actually thanks to the work of Carl von Frisch, who's the gentleman you see in figure B there, looking at the bees. And he, in 1914, published a study showing that he could condition bees to colours. And so it was very much like classical conditioning or Pavlovian conditioning, except in a bee. And he then extended this model to look at how bees orientate from the polarization of sky, which he published in Experimentia in 1949. And this is the famous bee dance, waggle dance, where they communicate with each other. He was invited because of that to go and speak at Princeton University, and there we now know Professor Einstein attended that lecture. This is research we only published last year. Because of some of our bee research, someone wrote to us and they had this lost letter from 1949 where Einstein had written, we may learn new things from bees if a new kind of sensory perception of their stimuli would be revealed through the behaviour of bees. And so it was quite interesting that one of the greatest minds of the 20th century was interested in the birds and the bees and what we might learn from them. And so I'm going to walk you through what we have learned from them and what it's starting to teach us for artificial intelligence. Can we go to the next slide, please? Okay, so I mentioned von Frisch showed that bees could be trained to colour or shape in return for a drop of sucrose. They're actually quite an amazing experimental model. The reason they make honey is an individual you see in your garden is not just collecting nutrition for herself, she's taking it back and giving it to the hive, and she'll come back and do the experiment all day for maybe 8 hours, collecting nectar in return for learning. And so what we can do is differential conditioning, where we train the bee to learn different stimuli, a bit like someone was showing a dog and a cat for how we might do supervised deep learning. We can do differential conditioning with bees. One very interesting thing we have seen is as the bees learn, we don't see actually a growing network, we see neural pruning. So it looks like the bee has a lot of despite only having 1 million neurons, has a lot of neurons sitting around which know how to do things. And as a particular problem is learned, the ones which aren't useful are tuned off the system to enable improved learning. I'll get to the learning speed in a minute. Can we go to the next slide, please? Okay, so this is actually the study which led to us being written to about the Einstein letter. So there had been some work in birds, in corvid birds, showing that they could understand the concept of zero. And so we employed some of the techniques which von Frisch had pioneered, and we wanted to understand, can bees learn some mathematical concepts? And so we conditioned different groups of bees. These are all individually trained, but there's 2 experimental groups and many control groups, to either select larger than or lower than numerical concepts. And then when we spontaneously present in a test the concept of zero, the bees trained to a lesser group selected this. So it means the bee brain can understand zero. Next slide, please. Okay, so we are seeing evidence of very sophisticated learning, but the speed is incredible. This is a comparative study we published 2 years ago where we looked at humans and bees in statistical learning. So statistical learning is a very contemporary way of trying to understand how humans are so efficient at what we do. I mean, people would love it if artificial intelligence could be as efficient at humans. As we cross the street, we can identify this, we can do many tasks. So in human vision, statistical learning has emerged as the leading sort of theory for how we solve these problems. And we applied the same learning paradigms to bees, and the bees were able to learn to a fairly good level the principles of statistical learning in about 200 trials. We actually had different experimental groups, say 120 group trial and 200 group, and the 200 group performed extremely high level. So this is much faster we might see with deep learning. Next slide, please. Okay, so we've been working with a variety of computer programmers and have been able to develop some new architectures which improve the efficiency of computing. So this is a reference people can easily look up. Next slide, please. We've also been able to show and other groups in the USA have used wasps as a model species, that there's amazing capacity to learn, and tasks which we assumed required a huge primate brain, but they can be done by bees and wasps. Next slide, please. Okay, so this is a study we also published which got a lot of impact, showing that bees could learn to add or subtract, so they can use colour as an operator to know how to solve problems. So this is very sophisticated use of short-term and long-term memory in the bee's brain in a very iterative way. Next slide, please. And this is a study which should appear in the next few days, which has just been accepted. We've just done the proofs for Frontiers, where bees can categorize or learn to categorize. Here's the important thing. They're learning to categorize numbers as either odd or even. And then we were able to build a 5-neuron network which mimicked the way the bees did it, and very quickly responded and very accurately responded to the problem. The amount of energy being used is far less than a classic computing system. Next slide, please, which I think is the final slide. Okay, so the take-home message. Computers power our economy, as many wonderful speakers are telling us, but we know it uses enormous amounts of energy, and it's taking a long time. I work with some wonderful computer scientists, and one of the issues we're dealing with is the time it takes to learn. Bees solve the problems with very few neurons for a drop of honey, and if we start to think about the bio-inspired designs, there looks like there's little software engineering tricks which could be borrowed from bio-inspired bees. Thank you very much.
Thank you, Adrian. I'm not sure if you can hear me, but thank you on behalf of the crowd. And I'm sorry you can't be here to mingle with the audience, but I'm sure if you have any follow-up questions, audience, if you search Adrian Dyer, RMIT, you'll be able to find him online and connect with him and ask your questions. Our next speaker is touching on a very important area in terms of applications of AI in health. Azadeh, and there are many others in the room. I see Ali, Ruan, others and myself as well, who work in this area of computer vision in health. So over to you, Azadeh, to talk about your work in AI in health.
Thank you so much, John, Rita, and the collaborative industries for providing such opportunity. I'm going to present AI in healthcare. And as John mentioned, many other people are working in this area, and I'm very fortunate to work in this area with them. Can you please go to the next slide? Thank you. Advanced artificial intelligence techniques have been used recently a lot and are going to develop to be used even more frequently in the future to provide optimized pathway for diagnosis and prognosis. What is even more interesting is they can develop personalized strategies for treatment known as targeted therapy or personalized diagnosis based on underlying genetics of an individual and analyzing potential risk factor for such individuals to provide more accurate diagnosis. A branch of artificial intelligence known as computer vision also is being used very frequently for analyzing images to detect anomalies and even patient-specific treatments, which I'm going to provide you an example of that in future slides. Would you please go to the next slide, please? Thank you. The first example I'm going to provide you of the benefit of using artificial intelligence in healthcare system is providing assistive technologies for patients. This particular example is actually a mobile application that enables diabetic patients to self-monitor themselves for development of the diabetic foot ulcer, and also helps them to identify the type of ulcer they have. Why it's important is because diabetic patients unfortunately lose the sensation on their feet, and they cannot feel if they are developing an ulcer because of high level of sugar in their blood or because of putting too much pressure on a certain area of the foot. So this development of ulcer can go undetected till it gets basically infected, and they can see the infection on their socks, or they can even see a blood tray on the pathway when they are walking. It's very disturbing and very unfortunate, but that's the reality. Many of such patients don't have good eyesight, so they can't even, try to look at it every day and decide if they are developing it or not. And some of these ulcers, as you can see in a left image number B, can be developed in a very tricky area, like between the toes, that can go undetected easily. What they usually do is they frequently visit the clinics, and they can help them to identify if they are developing such ulcer. It's very time consuming, provide lots of cost and burden for healthcare providers, and many diabetic patients fail to go and visit often because of the time consuming process and other tasks they have to do, or mobility problem. So this technology can help them in terms of early detection and identification of such ulcer and prevent advancement of the ulcer to unfortunately lead to amplification of the foot or serious complication, health complication. And it can even identify and separate mosquito bites from ulcer. Would you please kindly go to the next slide? Thank you. As I mentioned earlier, another benefit of using artificial intelligence, or in this particular example, computer vision, is to provide targeted therapy for patients. Patients with advanced breast cancer can benefit from different type of therapy based on being identified as HER2 positive or HER2 negative. It is usually identified and it requires a use of a specialized histochemistry test, which is very costly and needs a special equipment. However, artificial intelligence or computer vision can help by analyzing the histopathological full images and separate these images into HER2 positive and HER2 negative and help patients to benefit from targeted therapy based on their personalized characteristics. This particular project was also very challenging because there was no mask provided for cancerous cells, because to provide such mask, a manual analyzing of the image is required, and it was developed for more disadvantaged communities or as an additional cautious if such cells can be missed by professionals. And we showed that mixing deep learning with more traditional methods can actually perform well in separating HER2 positive from HER2 negative breast cancer patients. Would you please kindly go to next one? Thank you. It's just another example of showing more complex image analyzing techniques for detecting knee ligament injury detection and identification in 3D MRI images. This knee ligament injury more frequently occurs in athletes, and there are 3 different types of them. And to diagnose them, a specialist radiologist is required to manually go through images and identify if such injury is there and what type of injury it is, because it has 3 different kinds of injuries. This assistive technology can help with in more disadvantaged community that, and also with early identification. It's very important to know that, to notice and, emphasize that AI is not there to replace a specialist. It's there to assist them and provide with additional analysis of the image. If something is likely to be missed, they are there to help with detecting them, but they are by no means ever there to replace any specialist. Would you please kindly go to the next slide? Thank you. Talking about AI in health would never be completed without mentioning bioinformatics. AI is very advancedly and intensely used in bioinformatics field. I'm going to provide you with 2 examples here. They usually use as a predictive tool using machine learning techniques to provide some sort of prediction. For example, predicting the microRNA and disease association and providing the association confidence. It's very important to later on assist in the risk risk assessment for each individual, and even can lead to personalized medicine in the future. Thank you. I have to hurry up, I believe. Just one more point. It's although usually in bioinformatics, AI is used for prediction when we provide handcrafted features from having a sequence or a structural analyzing or functional analyzing or proteins, or describing the disease or microRNA in a handcrafted crafted type of features, they can also be used to detect more complex pattern in data, and the complex pattern that is likely to be missed by biologists. For example, in our work in predicting protein crystallization, we used deep learning techniques not for predicting the crystallizability of the proteins, but as a tool for extracting more complex features that were not able to be seen by biologists. The last slide, please. Just very briefly mentioning that, and by no means this presentation can cover all the work that has been done or can be done in using AI in healthcare. As John kindly mentioned, Ruan has done lots of work in this area as well, like, for example, incidental detection of prostate cancer. There are many other works such as, enhancing blood pressure, measurement by analyzing ECG or detecting abnormality in heart sounds. But this, I hope this could provide a very brief introduction to what a big contribution AI has in the field of healthcare. Just the last slide, please. Thank you. Thank you very much, everyone, for the time and the opportunity. I very much appreciate it.
Amazing presentation. I get the honour of inviting to the stage David Soroki, who's the Asia Pacific leader of AI and data from Dell, and Aruna Kalura, who is the Chief Technologist and also a finalist in the Women in AI Awards in Agriculture. So I'm super excited to have them both here. Dell was the first sponsor we brought on for CIAIRI AI Day, and it just really created a real domino effect. And we're so honoured to have you here today to talk about driving human progress with next-gen AI.
All right, thank you, Rita, and hello, everyone. I got to say, I'm pretty excited that I crossed one thing off my bucket list today, and that was hanging out with Spot and getting a little video and photo to send to my daughter. So thanks for bringing Spot along. Always wanted to meet him. Okay, so Dell's mission is to create technologies that drive human progress, and it's a mission we're pretty passionate about. It's something that's at the core of Dell and Michael's vision for the company. And entwined with that vision, I think, is our 2030 moonshot goals, where we really think about, as a company, how do we tackle some of the bigger challenges? In terms of technologies to advance healthcare, we've got global partnerships with organizations like TGen, where we invest significantly in supercomputer labs that are driving a lot of COVID and DNA-based research. But we also see that happening not internationally, but here locally. Just a couple of weeks ago, I was meeting with Stefan Kachel. He works over in the Austin Health Radiology Department. And he told me about this great little project that he'd been working on. And what's interesting about it is it also shows the power of diverse teams. You know, here's a IT guy who's had a 20-year background in radiology, a couple of grad students, and a senior radiologist. And together they were able to build a model which looks at organ segmentation, and instead of a researcher needing to do that by hand and taking 45 minutes, they're able to achieve that in about 45 seconds. And what's interesting to me about that is that's the power of building small, diverse teams. These AI projects, they don't need to start with a complicated team, a big infrastructure. It requires a couple of smart people with a vision, a diverse team with the skills that you can bring together. And it's amazing what you can accomplish when you bring together teams like that. I wanted to run a little video around Dell in AI. Dell's a company now, 130,000 people around the world. We do business in just about every country in the world, with a handful of exceptions. I think Russia just got added to the list. North Korea's in the list, but predominantly we're in most countries. So it means we're able to bring a lot of background and research and information sharing from some of the companies we work with internationally.
Artificial intelligence is everywhere.
It's no floor monitor.
It's in the appliances we own, the vehicles we use, and on our devices. It recognizes us, offering personal shopping choices and entertainment options. It provides medical breakthroughs, and it delivers business innovations that drive competitive advantages. AI is growing thanks to advances in data science, compute, storage, and networking technologies. At the same time, data is exploding, driving the need to adopt a data-first strategy using the power of AI. But how do you begin? It starts with an approach that brings knowledge experts into an AI center of excellence. Together, they create a plan that outlines the business problems to be solved, the technology investments required, and the bottom line results expected. From concept through deployment, success depends on an integrated, optimized IT infrastructure.
So looking ahead at where artificial intelligence and technologies are headed, there's a lot of questions I get asked as I talk to customers around the Asia Pacific region and here in Australia. And, you know, sort of three things come up quite often, and I thought we'd focus on these in the remainder of the time I've got with you. The first one is, hey, next-gen algorithms and where algorithms going. I think there's definitely a trend for larger and larger models. You know, initially when AI started, I think the large data sets enabled a lot of things, and we saw commonly labeled data sets like ImageNet and ResNet and the models that they were built on really start to create some new scenarios that were possible. But then as we innovated and the data sets became available, and you know, some of this was pioneered by social media. If everyone's uploading millions of photos to social media every day, some of these companies have extremely large data sets, and they pioneered the work and the trend towards larger and larger models. So we're seeing a trend towards larger and larger models with these algorithms. And then that starts to look at, hey, what sort of accelerator infrastructure and tools do you need to be able to put these models into production? And you know, sometimes you can start with a small model in the cloud, but when you want to put it into in a production and you look at the data volumes involved, scaling these problems out and these infrastructures out becomes a challenge. So I wanted to tackle a few different examples on that we're exploring, and also some practical solutions that we've got. And then also there's a number of areas where I think we're still not making AI easy enough and approachable enough. And I think too many IT departments are still focused on making IT easy for the systems administrator, but not focusing enough on what the researcher is trying to accomplish. And AI workloads have particular characteristics. And I think as an industry, we need to be more accommodating to the researchers to make it easier to be able to deploy these types of models. So the first example we wanted to talk about was with digital twins, and I thought I'd hand over to Aruna to talk about it. And it was quite interesting to see the digital twin model in the background there. So I'll tee that up, and why don't you talk about digital twins?
Thanks, David. Good afternoon, everyone. It's just a pure coincidence I got that plane there. I didn't know they were having a digital twin of a plane here. So what's a digital twin, right? It's a virtual representation of a real object, or with all its dynamics, whether it's temperature, pressure, everything included. And here we see the digital twin and a digital twin of a plane and the original plane. So there are sensors on the original plane where actually it sends all the information to the digital one, and the digital twin evolves just like the physical one does. So that's the important thing, right? And beauty of this is not just how we visualize it, it's about how we can play with the data, what we can do with it. So we have all this data, we can actually see how it responds if there is a problem. If there is a problem, how can we use it? How can we implement changes? How can we improve the whole product? The whole process actually takes a long time if we have to do in a physical one. So Dell works with McLaren to build digital twins. And McLaren normally takes about 5 years and $1 billion for a new model of a car. With digital twins, the time went down from 5 years to 2 years, and the cost went down from $1 billion to $500 million. So we can go through that innovation process quickly and move through that innovation. And not just that, right? Like we can think of multiple different use cases in digital twins. It's not just an object, but it can be swarm of drones. How do they perform? Or it can be humans. We have sensors all over us nowadays, counting the number of steps or heart rate and all these different things. What if we have a digital twin of ourselves? We can actually see how we are performing, right? Like not just from a work perspective, but like a health perspective, how do we actually get the things done? So if we can have simulate the diseases, if we can simulate what the treatments would be, how we'll actually respond. Again, Dell Technologies is actually working with for building a COVID-19 long-haul patient digital twin. So this will actually help identify what will be the long-term effects of COVID-19 on patients. So if we know something will happen in 5 years down the line, we might be able to treat it in 2 years or 3 years, right? Try to see how we can treat it. So there are many, many use cases, and I would like to watch this video.
Single press overtake, stay in scenario 7. Single press overtake. Scenario 8 out of turn 4, single press overtake.
Sorry. So this video is actually from 2020 Styrian Grand Prix. Lando Norris is the driver there. So what you see here is the driver is just sitting there, getting the instructions from the race engineer. The race engineer actually gets all this data from 300 different sensors, about 50 GB per car. In real time, they're processing it and giving the instructions. So that's the power of digital twins, right? Like this, we'll have digital twins everywhere, digital humans everywhere. So right now, there's work going on in building digital twins in banks. So you can have not the millennials, not thinking just about the millennials, but the traditional people who want to go to the bank, physical bank, they can have the same kind of feeling when they actually do a VR with a digital human, right? Same kind of experience. So the next topic, again, like we picked a couple of topics. There are more we wanted to talk, but due to the time, we just picked a few. We'll continue the conversation after this session. We'll be around or on social media, but this one is actually federated learning. So right now, most of the times when we are building these models, either it is in the data center or it is in the cloud. When we build these models, we are moving all this data. And at a certain point of time, we are generating so much data, we'll not be able to move it. The network, even with 5G, 6G, 7G, will not be able to move the data we generate. And we want to learn from this data at the edge where the data is generated, because the value of data decreases with time as well. So to do that, we need a platform which can learn at the edge from where the data is generated, and also learn from all these models together and build a global model. So what happens is we build these models on different edges. Like think about your phone, right? We have apps which identify us. And we build a model. Right now, all of this goes into the cloud. It identifies everyone and brings back the model. But what if we can actually build a model on our phone and send a model globally and club all these models together into a global model and send it back? It actually helps with privacy as well as the network bandwidth problem. And that'll be a big one where we can actually analyze both horizontally partitioned data and vertically partitioned data. The third topic I picked is actually quantum AI. So when we think about quantum computing, we think it's very far off, but there are some predictions that quantum will be in full-blown, fully blown and democratized by 2026. If not 2026, maybe 2030, right? It's not very far. So right now, the security we have, so we have all these optimization problems. It actually accelerates machine learning and AI algorithms and optimizes traffic and a lot of things. But at the same time, our current security is based on the hardware not being able to crack it in time. With quantum computing, it'll break it. So there's a lot of research going on in financial services organizations and also national security organizations to really build quantum resistant algorithms. How do we do it? We don't need to have complete quantum systems now. We can actually have a combination of hybrid of classical compute and quantum compute. We can simulate. Even when we have the complete quantum systems, it is actually a combination of classical and quantum hardware. And you can start doing that research now to build those quantum resistant algorithms and see how the security works or how the different algorithms work. So this will be another big topic which will change the way we do AI. With this, I'll pass it back to David to cover some of the considerations.
So one of the things we see with these AI models that are often worked on in research labs is how do I take them and scale them out and put them into production? And what we tend to see is that there's a variety of different options depending on how complex the needs are. So the needs to train the system can be quite compute intensive, and when you look at organizations like Tesla that are building their Dojo supercomputer in order to be able to enable self-driving and autonomous vehicles, it requires an immense amount of computing power to be able to build those systems. And organizations like that choose to build the infrastructure on premises, primarily because it becomes too cost prohibitive to do it in the cloud. When we look at something like GPT-3 as a language transformer, to do a single pass on that model and train it in the cloud would cost you several $1 million per training run of EC2 instances. So as we start to look at organizations that are putting some of these models into production, they often need caps and parameters around what the operating cost is of the environment so that they don't wind up in a situation where they start to negatively cash flow and become unprofitable. So designing systems that are able to support both research requirements to keep advancing the state of the art, but at the same time having a model and a cap on performance becomes incredibly important. The other thing that's important is also looking at data rates. Sometimes we might start with a system that is pretty small. We were going to share an example around a railcar inspection portal that we built, and I had a pretty neat video queued up. What we do is we take a series of rail cars and we run them through a high-speed scanner that's got cameras pointing on it. And there's a lot of sensor data and video feeds. And we scan the rail cars at real time. So you can imagine this is used a lot for multimodal transportation, where you're putting the containers onto the rail cars, and you might have a rail car anywhere from 40 to 100 carriages long. So that produces about 10 gigabytes data a second, running with 100 cars through there. The amount of data that's collected is just impossible to be able to upload to Amazon or even to ingest into a data center. So what we wind up doing when we build these railcar inspection portals is we process all of the data at the edge, and we design systems that can buffer all of that data, and then you can run the algorithms on it in order to be able to do the analysis later. So what we wind up doing is having a variety of different accelerator options. On one hand, you might have the deep learning requirements, which are very, very compute intensive. On the far end of the spectrum, you might want to do more inferencing at the edge, where it may be as simple as someone wanting to interact with a chatbot that's doing multi-language processing. So you might want to design a chatbot that can speak in multiple different languages to offload call center volumes and be able to run that on a website so that it feels like it's part of the end user experience. So some of those inferencing requirements are going to require much lighter volumes in terms of their inferencing compute capacity. So where we're able to help is provide that sort of consulting service where you're looking at the specific problem that you want to put in production and taking advantage of all the various accelerator options that are out there. So as we start to work with organizations, and some of this feedback is based on what we've seen from other university organizations around Australia, including Monash and University Queensland and their AI researchers over there. But what's interesting about it is, as I talk to different researchers, they're running into many of these similar challenges. They may have a university environment where there's a traditional high performance computing cluster, and that computing cluster might be doing a really good job at processing protein folding or doing some analysis on computational fluid dynamics to work out the airflow over an airfoil, or perhaps finite element analysis. And a lot of these traditional supercomputers, they're well understood, well run. Organizations know how to run those these days. But then what we also see is as we start to introduce AI workloads with them, these systems that were designed to do a great job with high performance computing aren't always doing the best job at serving the needs on researchers. So some of the practical problems that we run into is we see a researcher wanting to get access to a GPU to be able to iterate on a data science model, and that accelerator is not available because it's tied up in an HPC calculation, and it may take a week before there's a slot in order to be able to get to a GPU. And there's a couple of ways to solve that. You can call your local Dell rep up there and they can put a GPU under a desk, but often that winds up not being scalable, and organizations will have a mix of GPUs under the desk, but they'll also want to have some larger capacity in the data center that's more dynamic. The other areas that we see is often people want to test and iterate on algorithms, right? So, hey, can I design a better version of this algorithm that either is more accurate or faster? And often there's known training data sets that want to be used for those. And what we see is when that's often put on a system that's optimized to work really well for computational fluid dynamics, that uses a particular type of file system that works really well for those workloads, that's often not the type of file system that's really fast on a lot of small file I/O and training data that might be used for AI algorithm training. And so we start to see needs for reference data sets that are stored on specifically curated storage that accelerates algorithms. Another example there is there's a lot of libraries that we see. Nvidia, I think, has done a really good job, and you'll hear from them later today. I think right before cocktail hour, they're in between you and drinks. Nvidia has done a really good job packaging up their containers and algorithms into containers, but actually doing the work of taking those containers and putting them into productions, we're seeing that researchers are struggling with that, and some of that's a challenge, as when you look at the skill sets that are involved, a lot of the traditional HPC researchers might have more experience in Fortran and C. And then as we're looking at, and also Linux scripting, and as we're looking at AI researchers, it's increasingly Python and R. So that bridge to get data models where someone's understanding Python and R and bridging that into the computer science side of things, and understanding how to adapt a container to work in a particular environment, that bridge is still a little bit too far to be able to optimize those things. So we're often able to help by bringing teams and experts in that have done this before for other organizations and providing some consulting on that. Cluster management techniques to keep GPUs busy. This is another one that I think organizations look at. One of the traditional ways is first start off by expanding your HPC cluster and putting some GPUs in it. We see that being a pretty common technique. Often what we find though is that those GPUs aren't available as everyone takes them up. So then we start to often look at using commercial job schedulers that can better optimize the jobs, and that's a step forward in order to be able to make those GPUs a little bit more accessible. But in some organizations, we also look at virtualization. So the virtualization isn't something that's traditionally been done in the HPC world but it's something that we're increasingly seeing used in the AI world. So I'll give you the practical example I think about here is if I want to teach a computer science class to a bunch of AI graduates, and I've got 300 students in that class, it's probably going to be very difficult for me to provide 300 dedicated GPU servers at the last end of the quarter when that assignment is due. I'm going to be super busy for that period when the assignment's due, and the rest of the time, those GPUs are likely to not be idle. So as we look at the cost of deploying that, it becomes really hard. But as we look at some of these new technologies that exist, like BitFusion, we can share those GPUs on an interactive basis for specific assignments. It doesn't work with all workloads, but works with many of the ones that we might want to teach with a class. And it can be a practical solution to being able to run a class that you otherwise might not be able to offer to students. We touched on this subject of AI storage. Scaling federated learning across multiple nodes puts an immense amount of pressure on the storage system. Something Dell is really good at is designing scale-out storage systems that far exceed the capability of the storage systems you'll see in traditional on-premises supercomputers, or that you'll see in the cloud. So we're able to provide highly optimized storage for high-performance computing and AI workloads, and a lot of benchmark data showing you how to tune and adjust these systems to make the algorithms run faster. And this is something I think Nvidia are going to touch on a little bit more at 6 o'clock. They've got a terrific portfolio called Nvidia Ai for Enterprise that collates the latest Nvidia tools, packages them up into more of a traditional VMware environment, and makes them available to enterprise researchers on demand. So I think this is the beginning of more tool sets that are going to emerge in order to start creating environments that make it easier for researchers to get access to the infrastructure they need in order to be productive and work on these AI models. And the last one I think about is really sort of AI and machine learning as a service. You know, sometimes we have this challenge where we've got private and sensitive data. We often see it in the healthcare space where the sensitive data may not be something that you can easily upload to Amazon, and you might need to keep it more on premises with strict data governance. But you may want the elasticity of being able to provide on-demand services. So Dell's able to provide infrastructure on premises to give you the type of cloud elasticity that you associate with Amazon, but having it right in your data center to be able to work with the more sensitive models. So that's kind of a snapshot of where we've got some experiences. I'm not going to talk through these slides, but a lot of the things I've touched on have detailed white papers and follow-on resources and reading that you can read about. Most importantly, though, what I'd want to encourage you to do is your Dell account team can connect you with a lot of organizations and experience from other universities, from other organizations that are doing this on a commercial basis. And we've got a team of AI and HPC experts that are available so that if you're looking at a particular AI and research problem and, okay, how do I put this into production? How do I scale it? How do I operate it? We've got a team behind you that's done this for many, many other organizations that you can pull in, and they're happy to consult with you on your projects. I think we've got about 3-4 minutes left for questions, or we're not taking questions, Rita?
We can take a question. Why?
Sure.
Come on, we need a killer question.
Now, we will be available next door and during the breaks if you want to talk to myself, Aruna. Penny down here is the Dell account manager for RMIT. Give us a wave. Feel free to talk to Penny as well.
Right. Well, thank you very much.
You're welcome.
Thank you. I love seeing that part on the big screen. Thank you so much, David. And it was amazing to see some of the big tech solutions that you're doing, especially we got to feel like we were in the Grand Prix. It was pretty awesome. I'd like to invite you all to join us for lunch. Thank you, Dell. And we're also going to be coming back at 1:45. So we've got a longer lunch so you can check out what's going on. You've got to go see the plane. You've got to try mixed reality, get yourself a headset on and have a look at the human body. With Gig XR. So please enjoy the posters and have a chat to us during the lunch. Thank you so much.
All right. Can we get everyone? Can I actually get the speakers in the next session? Fabio, Iman, Ian, and Troy, perhaps up here. Maybe you want to move the seats around that way so that it's not awkward. There's a screen. No, it's a good test. I just want to, so they can see this up here. Otherwise, the screen in their necks. Thanks, Fabio. You want to move this in? Okay, so if I could please get the speakers, apart from Fabio, Iman, Ian, Troy, if I could get you up on stage, that way we can have a quick interchange, hey Ian, between talks. Maybe we can usher people in as well. I can see many coming in. Give another minute or so. So thanks again, everyone, for your participation today. Thanks to our sponsors again for lunch. I hope you enjoyed it. We had two interesting sessions this morning, one on learning technologies and the other on computer vision. We're going to take a slightly different angle this afternoon. Of course, learning technologies are applied in some of these cases, especially with Iman's talk, and we'll talk more about that. But the session's theme is mixed reality, all forms of reality, and it's quite pertinent that our first speaker is Professor Fabio Zambetta. Sometimes I don't know if this is real or if it's imaginary. He's Mr. Mixed Reality himself at RMIT, so I'll over to him.
Thank you. Hi, everybody. Good to be here. So my name is Fabio. I'm the Associate Dean of Artificial Intelligence at RMIT, so I lead the discipline. But when I'm not doing that, I typically do research in AI applied to computer games, mixed reality, intelligent user interfaces, and so on and so forth. So this is going to be a quick tech talk around some of the work that I do. But first and foremost, I'll talk a little bit about what mixed reality is. I'll make just a little bit of a note around some of the building blocks that have made all this technology possible. And then I'll show you some of the examples, a very small subsample of the work that I've been doing with other people at RMIT in this space. So first of all, what is mixed reality? So this is a little bit of an old classification that we still use as of today. Mixed reality can be conceptualized as a continuum, the virtuality reality continuum, as we call it. Essentially, the idea behind mixed reality is that you can mix reality through headsets or dedicated gadgets, dedicated screens, displays, and so on and so forth. You can mix reality with virtual audiovisual content. Sometimes it's even haptics content, so you can have gloves and other sensory inputs. For the purpose of this talk, I will concentrate mostly on audiovisual. So if we suppose on the left, you should see we have reality, so we'll assume we're not in a simulation today. On the right, on the far right, we have virtual reality. You have a headset, you're completely isolated from reality. Mixed reality is everything in between, a combination of real and virtual to some extent. Now, some of the key building blocks, HP was talking about it, Nvidia will talk about it later, and our very good friends at Xenon Systems, our sponsors, will talk about it as well. A few years ago, game technology that was developed to support 3D games, to support Quake, Doom, the games that all of you have been playing probably, created a breakthrough. So to power those games, Nvidia, AMD, Intel, and so on, started building GPUs. And those GPUs ironically ended up being the engine of machine learning and a lot of different scientific computing applications. So that has actually turned around the whole concept of simulation as well. And you'll see some of the applications in the talks that we'll be giving in this session as well. Now, what is some of the work that I've been doing myself with other people at RMIT and collaborators? So this was a project that was funded by the Australian Research Council, the ARC linkage scheme. Our industry partner was Village Roadshow theme parks, so the largest theme park operators in Australia, the largest entertainment company in the Southern Hemisphere. So we actually built and deployed the first augmented reality game in a theme park in the Southern Hemisphere. So at the time this work was going on, Disney Research was doing similar work in the Northern Hemisphere. So we built an augmented reality game that people could play while waiting for a ride during a packed day at the park. So the upshot of this is that while we did the in the wild study for this piece of work, we spent 1 full week at the parks for science. So the main technical result of this was that we actually built a control group of people going through the queue, and then we tracked people playing our games, sneaking through the queue. The queue, of course, was having its own motions. It wasn't fully free to move as well. And we actually were able to ascertain that, you know, by playing our game, people saw time go faster by 500%. Okay, very strong result. We published in some of the top computer-human interaction places. Another large project we've done in mixed reality, more, you know, traditional 3D and generating synthetic data, was in collaboration with Rheinmetall Defence Australia, a large multinational defence prime. And Iman is going to give a talk next, so I'm not going to linger too much on this, but we pretty much, what we did here is we tried to create synthetic data, virtual data, that can actually help alleviate the very time-consuming supervised learning that Ethan was talking about this morning. So by generating data in simulation, you can alleviate the time-consuming task of generating data and annotating, which is even more time-consuming. Some of the images of the environments we created in Unreal Engine and Microsoft ASM. Another project we built instead in-house has been in collaboration with the RMIT City Library. So this was the project that we pretty much used as a way of learning to develop on Microsoft HoloLens a few years ago. Once again, it's a blend of mixed reality and AI. It's a library tour, so you actually get guided through the points of interest in the library, and that robotic owl up there, our bot, was pretty much flapping around the user as you move around the library, and you get ushered through the library, and you get to see all the main interesting points. So it's an induction tool for student staff, and as you can see, there's like a waypointing system there pointing you to the next spot, and then our bot talks and gives you information and moves you around. Last project I want to mention, and this is going to be a good sort of segue into what Ian is going to talk about. Ian is the Chief Software Architect of our Digital Innovation Center at RMIT. So this is an application of mixed reality to education. So this was my sabbatical project. So back in the days where we could still travel, I got to spend my sabbatical at Microsoft in Seattle. And I worked with some of the lead designers at Microsoft Garage around this concept of a textbook that somewhat can, first of all, understand and gauge the student skill sets and preferences and so on and so forth. And then it can adapt the form of content and the level of detail of content that is more best suited for the student given the context. And so that includes, of course, different forms of content, such as text, audio, text-to-speech, etc., but it can also go into hands-on VR experiences and things of that kind. So very, very quick and brief introduction to the topic. I'm gonna keep it really short. Very happy to chat to all of you, any of you around mixed reality, and most people at RMIT know that that's what I do. Thanks John, Rita, Jörg, and Andy for organizing the event today. Thank you.
Thanks, Fabio. Well, he's kind of introduced all the speakers already on my behalf. So, well, as Fabio said and touched on, when you want to build machine learning models for especially heavy machinery, it's getting data is one of the most difficult things, right? Because you can't just run these things. So the project that Fabio mentioned is a good step towards that in terms of using synthetic data. And Iman did a lot of work in that project, and he's going to talk about the work he's done there, enabling us to create some of the synthetic data that we needed. So over to you, Iman.
Thank you, everyone. My name is Iman. I will be explaining about actually a Skongan, a method that we actually presented to use some kind of computer vision and machine learning algorithm to increase the amount of data set that we created using the game engine that actually Fabio presented for the Rheinmetall project. Okay, as all of you know, all the like machine learning and AI models are data hungry. So actually, as you can see in this slide, when we increase the amount of training data, actually you can see the error, and obviously the error will drop and accuracy will improve. You can see, especially with deep neural networks, actually the amount of data matters a lot. When you increase the amount of your data, the error for that problem actually drops enormously. But as you all know, like actually data collection is very expensive. For example, you need to ask human to like first collect the data, and after the collection, a human needs to like go and like annotate it for that specific task. For example, let's say this like autonomous driving like pipeline, we need to first collect the data, and after collecting the data, we need to actually find the objects into that like video that are collected, and then actually once they are collected, they need to be annotated, and then after the annotation, we need to actually keep them in a like safe and actually secure place. So which all of them is costly for companies and research institutes and everywhere. So what are the actually conventional approach? What are the the methods that usually used to actually face these problems of data collection? So one of them was actually using synthetic data, as Fabio explained, or for example, you can see in this slide, actually we can use some kind of game engines or actually some computer graphics softwares and create some realistic facial, for example, humans, or actually a street for actually solving our problem and expanding our data sets. Or another approach which is mostly used is using, for example, data augmentation. As you can see, for example, for this project, which is kind of actually detecting human body or detecting a person in an environment. To increase the amount of data, we can just kind of actually augment the data, for example, rescale it, or actually put it, repose it, or put it in different environments to actually increase the amount of data for solving that data collection problem. But there is always a gap between the real and synthetic data. As this project that I did, for example, it was for human expression recognition. So what we did, we actually try to use some kind of, again, computer graphics technique to increase the amount of data that we had. But actually in our experiment, we realized, okay, not only synthetic data or actually real data will help us. Once we actually combine them together, the accuracy will increase. But the problem was actually the gap between the real and synthetic data was there, and actually the machine learning models, they couldn't actually learn properly. But can we use like the advanced machine learning models, computer vision models to actually reduce this gap? So you can see here in this actual slide, this is on the left side, it's a GTA game engine, and on the right side is using some machine learning models. They call it generative models, to actually, it's added on top of that game engine to kind of actually enhance the quality of the image, to actually make it more like realistic. Then this model will actually reduce the gap that was actually there for training the machine learning models, for example, for autonomous driving. So the project we were working on, as Fabio said, actually we created like an environment. It was mostly Australian environment. All the objects and the scene was actually in Australia, but like the partner, the industry partner that we had was actually looking for a model that can be like applied in different environment. In like they can use their models in like America, Germany, or even in Australia. So we had to. It was very expensive for us to actually again go send a team there and start collecting data in different like weather conditions. So we start looking at like computer vision algorithms to actually find a method to transfer the data that we had or we created in the game engine and actually transfer it to some other area or some other domain. So let's say, for example, summer to winter, or between different weather conditions. But our method was actually we wanted to have more freedom for creating the data that we have. So besides using just the domain parameter that you can see, for example, in this slide, which is for example set to 0 or 1, which is like summer or winter, we wanted to stylize the image that we had. So we also introduced a third parameter, which we call it reference style image, to actually train a model that can actually transfer the image and re-stylize them based on the reference image that we had. So I don't go into details, but obviously I'm around. If you had any questions regarding the details, feel free to ask. So here are some results. For example, you can see, for example, on the top row, it's all the original image, and on the left side, it's actually the reference, and the generated one is actually the image next to them. You can see, for example, based on different reference style image, we created actually different like image in the winter domain, and you can see actually the results are like kind of very realistic. To also see how our model performed, we did also a human evaluation on our actually generated results. We used 180 images. Actually, we showed them to like 50 participants, 90 real and 90 fake images. And actually, as you can see, like we could successfully actually kind of full human by using our method. So the method we introduced was actually even from the point of human, and human evaluation was actually very kind of accurate. So here are a few examples. You can see these are the real images that actually human were kind of was mistakenly actually chose them as, for example, real image. As you can see, like for example, on the right-hand side, these are real images that were actually selected by human as real, and on the left side, it's a real image that was selected as fake image, but this is a real image. And here is actually the generated results from ours. On the top right is actually, on the right is kind of the examples that were successfully categorized as fake image, and on the left side is actually categorized as real image, but these are all fake samples. And so this is a video, if they can play it. So this is actually the game engine on top, and we use just one reference image. And as you can see, actually, we were able to transfer the one Australian scene that is in the in actually kind of summer domain. We transfer them to a winter domain to train our machine learning models. And yeah. That's all from me.
Thank you, Iman. I think you've also highlighted the point that we probably should redefine the Turing test these days, right? So many algorithms can fool humans these days. It's certainly one of the most interesting projects that I've been part of, so it's great outcomes that we've got there. So we're going to take a slightly different twist with Ian. So we talk about tech and technology that we've advanced. Ian's going to tell us a little bit how we've taken mixed reality and applications of this to the non-tech world in some sense through the Center for Digital Innovation. Over to Ian.
Thank you, John, and thank you everyone for coming. Yes, so I have the privilege of working with the STEM Center for Digital Innovation, a new startup inside RMIT, which is focused on world-leading teaching through digital innovation. So I get to work with academics and also with students, as you'll see, particularly with students in their productive part of their program where they work on capstone projects, particularly software engineering and computer science projects. So I'm feeling amazingly grateful to be where I am. Provocative title, Success Virtually Guaranteed for Trainees in Complex Real-Time Physical Environments. So the case study that I would like to look at from our year one highlights of the centre is something we call Clinic Sim VR. And then I want to talk a little bit about strategy. So my role as a solution architect, I'm thinking about how can we do this not just for one project, but for several. So the case that I'm particularly focused on is around the nursing labs at RMIT Bandura campus. So they train nursing students who have to become competent in a hospital environment. They have these simulated hospitals with mannequins that can be controlled and animated and have an operator pretend to give the patient symptoms and problems and all kinds of things. And there's actually, interestingly, there's a significant IT training part of this process that the students have to get used to. And then there's an assessment component. So of course, typically the academics are very protective. They want to make sure the students do well, but the students can sometimes come unstuck in just using the IT systems that come as part of this simulated hospital nursing lab. So we had a conversation with these people and asked, could you make use of virtual reality system? And so they came up with this thought that maybe we could onboard students, because this is a hospital, a highly used hospital environment, that maybe there's a way that students could be pre-trained to use the IT systems in this environment. Click up, there we go. So if we can have that first video, please. So this is what one of our computer science, computing technology capstone teams came up with. They're a little bit self-directed, so they've come up with some approximate models of this clinical simulation environment. You can see that there's some props there that are in the hospital environment, and then there are some IT systems. So there's a login screen. The students have to be able to log in with their student number. They have to be able to interact with these different applications on, there's 3 different screens in this room. On the left-hand side, you'll see that once they've logged into the clinical assessment system itself, then a timer starts and the student has a very small amount of time then to interact with a mannequin, a patient in the bed, to talk to the patient, to get symptoms. They have to log into this system on the right-hand side, and they have to be able to switch between 2 different views There's first of all the Canvas login system, and there's a patient record system, and then there's also a clinical signs, heart rate, respiration rate, and so forth. So they have to be able to do all of this in a very similar amount of time to what I'm doing up here, that they have to perform in a short space of time, stand on a cross, talk to a camera, and say, this is the finish of my clinical assessment, and so on. And understandably, the students sometimes can't get all of this done in the amount of time, and they can, just going to log back into my system here, they can find it quite difficult to do this all in the space of time that they have. So then, having developed this system with our student capstone team, then the question is, what do we do next? So this is far from the finish of, this is really the beginning, and this process then requires us to do some evaluation. The students have developed this system with an Oculus Quest 2 headset. Nursing students are not likely to be buying particular kinds of VR headsets, and more likely they're going to be dealing with something much more like a desktop system or a mobile phone. And so we need to think about how are we going to translate this experience, which is already somehow an approximation, with something that is suitable for use on a mobile device with even more constrained interaction. And then the bigger question is, well, we're interested in both the teaching experience for particular courses, but also for digitized facilities or digital labs. So how do we scale an experience like this, our experience and also the experience of academics, to a much larger range of courses? And so one of the thoughts we've had is that we would like to focus on RMIT facilities. RMIT, in some sense, has a reputation for its labs and its facilities, physical environments, and would like to be able to access those remotely or in a time-shifted way. But there are all kinds of challenges here. So just picking out some P words, we have productivity. How do we make this work with a limited number of staff who may be available to have the technical experience to develop applications? The process, how do you go about doing this without messing it up? Partners, one of the most powerful ways obviously is to work with companies that have this expertise, and there's plenty of companies emerging. We could name big name companies that would be great to work with. Platforms, and then the fundamental problems. There's so many issues that still have to be worked out. We're in the very early days, even though, as Fabio says, we can see a convergence of gaming technology, AI, mixed reality, simulation. We still see that there's much work to do. And I wanted to focus on one particular thing in the remainder of the talk, which is on, I guess, a technical topic, which is of reuse. So if you think about the way that people develop virtual mixed reality applications, one of the most popular things to reuse is one of these assets or models, a 3D model or something simpler. And just reusing a 3D model by itself may not be very easy, or at least if you are reusing a 3D model, that may itself be easy to reuse, but that's only capturing part of an overall process that has to do with the logic of the behavior of that 3D model. And let's say if it's a hospital bed and it comes with its own logic, that you have to be able to know how to operate the hospital bed, and it has controls of its own and so on. So being able to reuse not just a 3D model, but something more than a 3D model is kind of a challenge. And I'm really just unpacking a little bit of this today, and I would like to reflect on some of the experience that I've had in an earlier phase, and bringing this into the centre. So I would have liked to have mentioned Mozilla Hubs. We probably don't have time to play this, but Mozilla Hubs is a very interesting platform which has many of these attributes, like a multi-user access, the ability for people to drop in models and so forth. It has the ability to use these different kinds of assets like images and video and so forth. It has the ability to be used on a variety of different devices. It's open source, it's free, it's accessible to use. The Mozilla Corporation have done a really good job of making this something that you could imagine people using. And now we're going to see the standard battle playing out between open source on the software on the one hand and large corporations developing big and hefty products that they want people to buy into. So in my past life, or in a present life, I look after a space called the Virtual Experiences Lab. And if we could just have a little snippet of this video, we've been exploring all kinds of combinations of robotics and virtual mixed reality, visualization, user experience, all in the context of student projects and enabling students to have a real world development experience on something a bit different. And these students then hopefully graduate and can use their skills in a real life setting. That's introducing the idea of robotics and robot operating system. If we could just play that next video. One of the things, the platforms that we use in this virtual experiences lab is robots that run on this platform called Robot Operating System. And this enables us to explore concepts like digital twins. And here's Rosie, our kind of celebrity robot, off to the Grand Prix this week, following a student who's developed a vision system that just does basic orange blob detection. And Rosie follows him around the room, and it's safe, don't worry. And you can see in the bottom left that this has been used to drive a simulation, or kind of a simple digital twin of the lab. And you can see that there are elements in that space, like this little other robot, this little white rectangle, and the lab model itself, that these all become the kinds of things that you would like to reuse as part of a simulation. And so I guess what we're driving at is that simulation and simulation technology is one of the things that people are going to bring to this space. And then just a brief mention at the end that Robot Operating System has this ability to do more abstract communication pathways. This is a software engineering talk, briefly, that there are solutions that enable people to disconnect and break up simulations in a way that you could use to develop virtual reality systems in a way that would make it simpler for people to use much more complex assets. And that's leading to one paper that I've worked on with a colleague on simulation components in this robotic simulation environment. So finally, just to mention again of the Digital Innovation Centre, we talked about a few different kinds of platforms that we want to work with going forward. Things like open partnerships, sustainable platforms, and digitised facilities. So we've talked about this theme of digitised facilities. Open partnerships and sustainable platforms is a part of how we see that we could work on strategies with a range of different partners, but with a preference to doing things that would allow us to put some of these assets that are being developed in the bank, or for us to be able to use those assets on a level playing field. So those are some of the themes that are coming up in my environment. So thank you for your attention.
Thanks, Ian. Probably should also give a shout out to James Harland, who is the director of the Center for Digital Innovation. James, so if you need to know more about the center and center activities, Ian, James out there as well during the next coffee break. So to wrap the session up, speaking of cool applications, Troy is going to talk about how we use mixed reality, or he's used and has ideas of using mixed reality to connect urban environments through play. Over to you, Troy.
Thanks, John, and thanks, Rita, for inviting me to be part of this event. It's really been an exciting day full of robots and AI and all the things that inspired me to get into games, which is where I spend most of my time. Just to give you a bit of context, I've trained as a designer. I'm currently a research fellow in design in social context. But most of the work that I do is in public space, and so it's really this intersection of play, design, and cities. And so I'll be talking about this in the context of Future Play Lab, which is something that I've set up here at RMIT to look at this unique, I guess, confluence or convergence of creative and technical kind of disciplines, of which mixed realities are really in the center. So to just explain a little bit more about myself, I guess the term I use to describe what I do is artist game maker. So I'm working with games, but in a very, I guess, a context of an art practice. And I'm going to be talking today mostly about urban play. So what we mean when we talking about engagement with public space and how AR and mixed realities and particularly mobile devices interact with that. To give you a cross-section of my expertise, I'm a self-taught coder. I practice as an artist and, as I said, trained as a designer. So the project I'm talking about today is 64 Ways of Being, which is a creative state commission. So this is a project that Creative Vic essentially initiated as part of their first Creative State program. We're in version 2 of Creative State now, so this is the one before the pandemic, which was largely about, or the Creative State Commission was largely about developing projects using creative technologies that engage people with place. And so our response to that was a platform for urban adventure that used mixed realities as a way, not so much, I guess, in the way that Fabio was talking about it, in that's that kind of famous spectrum of VR to AR, but starting with place as the foundation. So it's kind of anti-Pokemon Go, because we're starting with place and we're kind of creating these bespoke AR experiences that respond to that particular place. In this case, there's an image of an experience that we've created along the Burrarung, the Yarra River, which talks about the both environmental and Indigenous history of that location. So when to put this into some kind of broader context, the work that I do is around what we call playable cities. And this is kind of started out as the antithesis of smart cities. So how can we, because smart cities in the first iteration looked at, the city as a platform and how, every city was the same. Playable city kind of does the opposite. It looks at how we we live in our cities. It's about that lived experience. But what I'm also interested in is what we might call civic identity or the social imagination. And over the last few decades, we've had all of these descriptions of cities as being creative, livable, lovable. I think the current one for City of Melbourne is possibility, city of possibility. And so this is a kind of a great interest to me in that we're kind of living in this complex system which interfaces with, over the past 2 decades, increasingly with all kinds of creative technologies. But still, to make those relatable, we need to think about lived human experience. And so this is where I really use play as a methodology, particularly this idea of urban play and how adults engage with play, and then that doesn't come naturally to adults. But there's I won't go into all of the layers of complexity that come with being in a state of play as an adult, but there's a few of them there. We have all of these ways that we can, I guess, shape reality, which is really, for me, fundamentally what mixed realities are about. So to just break down really quickly what urban play is. It's a bunch of different things. It's quite diverse. It's free analog play, so no tech at all, apart from maybe a hopscotch path. Play with technology itself. This is a street lamp that's been made into a kind of dance performance. Mobile play, as I said. Play with infrastructure. This is a playable art tram that I developed for Melbourne International Arts Festival a few years ago, so uses AR to turn the tram into a musical score. Play with location, as I was just talking about. Play with strangers. And playing with the city as a material, taking the city and using it as a ready-made game world. And so in this project, 64 Ways of Being, some of these kind of ideas come out, and I'm going to kind of briefly talk to that project in a moment. To get there, though, some of the reasons for playable cities, there are many. So the first and foremost is connecting people in place. But it also has this impact on public health and societal well-being. So if people feel connected to place, they're more likely to be feeling, happy within themselves and happy within their environment and so on. And so it has all of these follow-on impacts. It also allows us to reimagine public space. So it's something urban designers and urban planners sometimes work with. It opens up approaches to wicked problems. And of course, it crosses over with placemaking and wayfinding. So urban play really is expanding game culture and technology and putting it into public space. So looking at all of the complexities of, the street that's just out there, Swanston Street. Once you go out there, kind of the problems that you're working with become huge, and also opportunities become vastly expanded compared to what you're kind of working with in the lab. So we work a lot with, in the Future Play Lab, with the city as a laboratory. So this is an image from a project where we were experimenting with a parklet late last year in terms of how people interface with public space. So my art practice really is kind of, I guess, what you call mixed reality art. And what does that mean? So it's concept driven rather than technology driven. So I'm not, I appreciate kind of, I work on all of the kind of existing platforms and kind of pushing the possibilities of those. But it's also connected to kind of speculative design and imagination, and it's very interdisciplinary and collaborative. So to briefly introduce 64 Ways of Being, I'm going to play this short trailer, and if I can do so from, oh yeah, here we go, to give you an idea of what the experience is like and what the thinking behind that is. So to wrap up, really, 64 Ways of Being is an experiment in mixed realities that's using existing technologies. So it's built in Unity 3D and Vuforia, using the Vuforia engine. So nothing particularly experimental from a technology point of view, but from an experience point of view, it tries to bring together game design, public space, and theatre. So to create a different type of experience for the player and to recontextualize mixed realities in terms of I guess, an art and cultural context, and to take the city as it is and soundtrack it, the music synced to particular GPS coordinates. The AR experiences are created for particular laneways and locations. And it's essentially a show as much as it is a game. In fact, if I was going to describe it as a game, I'd probably describe it as a walking simulator, except you're walking in your actual body. Thank you. Oh, and also come and play the demo in the coffee break. Cheers.
Well, there's a lot of cool technology going around, and indeed mixed reality is at the heart of it. So let's once again thank our speakers for this session. Thanks, guys. We'll take another short coffee break so we get to mingle. Demos at the back, coffee is just outside. Please visit the demos. They're here to talk to you, and also mingle amongst yourselves. Try and talk to someone you haven't spoke to already, especially not the same people that you work with, ideally people you're not with before. And we'll see you back in 20 minutes.
Can I get you all to come back in and we can start the session? How are we time-wise? Good. Okay, let's get to the next session. We have an interesting set of speakers and topics coming up around agent-based decision-making. A lot of AI really gets used in businesses to make decisions, and agents are currently not talked about as much as machine learning, but they're very much an established part of the AI methodologies. And so we'll start off with Professor John Tangaraja, and his topic is, why did the AI chicken cross the road?
Thanks, Jörg. Given that it's a non-ML talk, I had to make at least the title attractive to you. So let me indulge you in the next 10 minutes on an area of AI that I've been working on for almost 20 plus years now. So when we build autonomous systems, we often want to ask or query, introspect the autonomous systems to figure out why is it doing what it's doing. So in this case here, imagine I created a autonomous chicken robot, and I see it crossing the road, and I want to ask the question, why did this AI chicken cross the road? Now, if you follow the machine learning techniques for the decision making that most of the speakers talked about this morning, you give it a series of inputs, it's going to feed it to a neural net, get an answer and say 0.68. That's the reason I'm crossing the road. If it was a game theoretic agent, a chicken, it might have some sort of payoff matrix somewhere, and it looks at it and says, well, that's the dominant strategy. That's why I crossed the road. But if it's a chicken that was built using cognitive agent technology, the kind of chickens that I've been working with for 20 odd years now, it would come up with an answer that looks like something like this. The reason I'm crossing the road is because I have a goal to find food, and there were two things I could do. I could explore across the road or explore the next street, but there's food I see around, so it's safe to cross. Because of that, I took the action to cross the road. And the next thing I'm going to do is look for food. So these are cognitive agents because we build them using cognitive concepts. So if you take one of these, so you see the now robots outside there, and so let me elaborate a little bit on what these agents do. In a nutshell, the reasoning cycle is very simple, right? You observe, so the robot sees a ball across the room, it figures out what to do. Well, I'm going to walk up to it. Then it acts. I take the steps towards that ball. You observe again, I'm at the ball, what do? Well, I'm going to kick it. And then it acts and so on. So these agents are autonomous in the sense that they can behave without human intervention. They are proactive in the sense that they have goals they want to achieve, and they're persistent in the way they achieve those goals. If some way of achieving it fails, they'll try another. They are reactive in that if I'm walking towards the ball and there's an obstacle, I'll walk around it. They're rational. If I'm playing soccer, I wouldn't turn around and kick an own goal, because that wouldn't be rational. They learn, so over time they'll start learning what behaviors work well and which don't. And they're social, because they're teams, so they need to be able to communicate. They need some sort of shared knowledge, shared understanding of how to act as a team as well. So these are some of the common features of these cognitive agents or these cognitive autonomous systems that I talk about. So basically, what we've been looking at in RMIT for a very long time now myself and also my colleagues as a team, we've been looking at using these cognitive concepts of the goals, beliefs, percepts, actions, and so on to design and to implement autonomous agents and teams of agents. We look at how do we develop and implement reasoning behaviors, right? So you have a goal, how do you be persistent with this? How do I make sure that if you have two goals, for example, I want to give this CRA talk, but I also want to be at the beach at the same time, that clearly conflicts. How do I recognize those conflicts in an autonomous system? How do I manage these conflicts? How do I schedule these different goals, these intentions that I might have? Then the question we talked about with Hung's talk as well in ML algorithms applies here as well. How do we test these autonomous systems? It's a very important aspect. Now, most of the work we've done in this space has been in simulation and training systems, but of course you can put this on physical systems as well, and some of our industry partners have done so. Then more recently, over the last, recent if you consider 5 years or so, we started looking at this notion of human agent teams, in particular with our partners from DST group, and some of them are here. I see Pete in the crowd here, and Dan Pope was here too. We look at human agent teams. How do we build an agent system where the machines or the agents and the humans are true collaborators? Not that the human uses the AI, but it's part of it in the sense they work as a team. So how do you share the knowledge? How do we explain behaviors? How does an agent explain their behaviors to humans? And how does a human explain the behavior back to agents, right? And we want to do this in intuitive ways. So to do this, at RMIT, we have a lot of expertise in agent design methodologies, and one such methodology is TDF, the Tactics Development Framework, work that I've been leading for about 7 or 8 years now with Rick, who's going to give a talk soon, and at the back there we have a demo on TDF, and this is a methodology we've developed with DST Group. I won't go into too much detail, I don't want to steal Rick's thunder. But I just want to mention that we do have a book that we published. It's on Amazon, bestseller. You better get in quick. It's selling out really fast. Also, designing systems, you got to be able to implement them. So if you design a system using these cognitive concepts of beliefs, goals, plans, and all that, great. But to faithfully implement them, you also need what we call an agent programming language. A programming language that supports these cognitive concepts. So Sebastian Rodriguez was actually meant to give this talk right now, but unfortunately he's ill and he couldn't make it. But Sebastian, together with collaborators in France, have developed an agent programming language called SAL. And SAL is an open source agent programming language. There's a poster at the back as well. And there's another Sebastian in the room, and he or I is very happy to talk about SAL in more detail during our networking event. And there's another system called Jack that we at RMIT have used for almost 20 years now. That's developed by a company called AOS, Agent Oriented Software, who's down the road here in Carlton, who are long-term collaborators with us. So going back to explainable AI then, if we go back to that initial problem of having this chicken crossing the road, if that autonomous chicken was designed using our TDF design models and implemented in a system like SAL or Jack, what we can do is trace the runtime execution. So as the chicken takes its steps, as the autonomous entity starts doing behaviors, we can trace them back to the design models. And then we can answer these questions of why did the chicken cross the road, or why did machine or entity X do action Y, in terms of these cognitive concepts, in terms of goals. As I said before, the reason the chicken is crossing the road is because it chose to adopt the plan to explore across the road because it was safe to do so, in order to fulfill the goal of finding food. That, I think, is much better than 0.68. The other thing that you can do with these intuitive cognitive models that you and I as humans are so used to is also perform intention recognition, which is at the heart of this. So you want to, when you work with human machine teams in particular, humans need to be able to understand or try and figure out what is the intention of those agents, and vice versa. So again, if you design and implement system with these cognitive concepts, it makes our life a lot easier and those reasoning methods much easier. So here are some industry-led projects that I've been part of, just a few of them. As I said, one of our biggest customers is defense, and we've done lots of projects with them. I'm not going to go through all of these in detail, and the reason is the next three speakers are actually going to talk about these cognitive systems, slight difference in their application, and they're actually going to show some applications that they've used themselves. So I'll end there. Thank you.
Thank you, John. And as already said, the next speaker is going to be Rick Everst, and he's going to go deeper into the details of TDF.
Okay, so it wasn't planned to be a big overlap because John's a fill-in, but it's quite good because he's explained a lot of the concepts for me already. So, these days people spend billions on building submarines, etc. So if you're going to spend that much money, you want to make sure that you build the kind of submarine that you'll need in the future. And the way they do that is by doing what's called capability analysis. So you do simulations. So you say, well, what would happen if we had the $10 million sonar on a submarine? Is it that much better than the $5 million? I don't know how much sonars cost, but probably more than $10 million. And then they run simulations. And they'll run like 10,000 Monte Carlo simulations, changing variables, and see what the outcomes are. Was it worth having the better sonar, or wasn't it? But in order to run those simulations, you need to have the submarine behave as a real submarine would, driven by a real submarine commander. So you need to put proper submarine tactics onto the simulated submarine so that it behaves so you get realistic outcomes. Another area which I've worked on in the past with agent-oriented software that John mentioned before is live fire training. So you have these robots running around and special forces are practicing their shooting. And you don't just want it to scatter, like come running towards you, because real humans wouldn't do that. So you want to put realistic behaviors onto the robots so they behave in a realistic way, run for cover, or whatever real people would do in that situation. So more generally, you can think of those robots as an autonomous system, which they are, and the simulation, they're not what we call autonomous systems, but the reasoning that they do is what you would require on if you had, for example, an autonomous submarine. So what we want to do is build autonomous systems that intelligently assist us to achieve our goals. And a lot of problems people have at the moment with autonomous systems is you give them a goal and you think that they're going to work on that goal, and they do, but because you haven't fully constrained the problem, they go off and give you a solution that you don't want. And another thing that we want to do now and into the future is to work together with autonomous systems in teams. So have them as, teamed with humans. So they need objectives or goals to achieve, and then obviously they need a means for achieving that. So they need to be able to form plans to achieve those goals. And because they're, embedded in the real world, then they need to be able to react to unexpected situations and deal with them. And as I said, work with us in a team to achieve the joint goal. Another term that's big these days is trusted autonomy. So if you have an autonomous system and you have, a human involved with it, could be a pilot on an aircraft, then when do they override the autonomous system and when do they not do so? So really what's important here is not to trust the system, but it's, that's working, went off here. It's not to trust the system, but to have calibrated trust. So you trust it when you should trust it, and you don't when you shouldn't. So in order to do that, the machine's reasoning needs to be transparent. You need to be able to know what's the machine trying to do right now, and what is it basing its decision making on. So what does it, maybe you know something about the situation that it doesn't know, and so okay, well, I need to override what it's doing at the moment. So the system needs to be able to explain itself, and so if it can do that, and if we can see why it's making its decisions, then we can reliably decide whether to override or not to override. So at the moment, when you program these systems, you get something like you see on the right there. So not really suitable for inspection by a human in real time as it's doing its decisions. So the question is, how can we explain this system's reasoning to the human, or how can it explain its reasoning? So our approach is using what John was showing before, so this graphical representation. So it's showing that there's a percept coming in, it's an incoming missile, and the first thing that it does is it calculates the ETA, then it deploys its countermeasures and evades the missile, then does a few actions, turning away, changing altitude, and then accelerating. But at each stage, you can see what it's doing and why it's doing. So the reason it calculated the ETA was because it was handling an incoming missile, for example. So by having that diagrammatic representation, you have, the human can have some understanding of what's going on. So we've developed the tactics development framework, and there are various things you can do. You can use it for knowledge elicitation, so you sit down with an expert and diagrammatically map out scenarios, so this kind of things the system needs to handle. You can represent strategies, so the goal tree like you saw before, system architecture, what agents do we have, what do the teams need to look like, and also what are the tactics and plans. So here's an example, you probably can't see the detail, but that's the sort of thing that's the way we represent case studies. So it's diagrammatic. It moves from left to right, and there's messaging going on between different participants. There's one participant on top and one underneath. So here's an example of the sort of representation that we have. So on the left, there's a strategy diagram. And so the first goal is to recharge the battery. It has two ways of doing that. It can either go to a recharging station or it can return to base. So the first thing it tries to do is go to a recharging station because it wants to achieve its overall goal. So it finds a suitable charging station, selects a charging station, and then it reserves it, moves there, docks and charges. Now, if any of those fail for whatever reason, then it has an alternative solution, which is to return to base. So that's like a high-level strategy that you can show someone as the machine's doing what it's doing, and they can understand the high-level goals and why the sub-goals are being pursued. And then on the right, you have the agent diagram. That shows all the capabilities that the agent has. So there's a recharge battery goal. Underneath it has two plans for doing that. And if we go down to the bottom, we can look at an actual plan for recharging. So on the left there was the part of that agent diagram. And then on the right, you can see the details of the plan. So it's graphical. So as the agent's doing what it's doing, you can step through and see. So the first thing it does is it has the goal to reserve the charging station. It sends a message to a ground charger and says, I need a time for you to go to a certain location so I can charge. And then various things can happen. Either the recharge request is rejected, maybe the charging station is busy, it's already fully scheduled, in which case that plan fails and it might find a different way of reserving a charging station. Maybe there are other chargers around. Or it might succeed, in which case it gets allocated, it stores in its belief set where it needs to go, and then it can go there, in which case it's succeeded. Or maybe it knows it doesn't have much power, so it can't wait around too long for a response. So it waits after 5 minutes. If it doesn't get a response of any kind, it decides to abort and do it differently. Okay, so we've worked in, over the years, like John was saying, 8 or 9 years, we've worked in various domains, air combat, bushfire modelling, search and rescue, human agent teaming. So in training scenarios where normally you would have humans driving a simulation and there's a trainee, now you can get intelligent agents take on the roles of those humans who are doing those particular jobs. And then also undersea warfare, so the submarine sort of stuff that you saw at the very beginning. So currently we're working on explainability, so tracing those strategy trees, and also automatically generating plans from those strategies. So you draw the goal tree and it will generate those plan diagrams that then get run by the agents. And finally, we're working on automated code generation. So it's not just, we're not just drawing pretty pictures, those will be used to generate code, which when it's running can then show what's happening on those graphical diagrams. And I've got 7 seconds, pretty good. Okay, thank you very much.
Thank you, Rick. And next up, we have Dhirendra Singh, and he's going to talk about how he's going to help keeping us safe.
Okay, I'm going to continue with the theme of these cognitive agents you've heard about. So this is still going with the idea that you want behavior to be explainable. And I'm going to talk about how we're using it in the context of modeling communities and how that work is helping emergency services understand the risk to communities from natural disasters. And I'll use bushfires as an example here. So this is an ongoing project. It's been running for many years with through CSIRO and working with local governments in Victoria and the state government as well. Okay, so we know that bushfire risk is very real for a lot of the communities around here. This is a photo from Gisborne, not very far outside Melbourne. And the question that we're really interested in here is, when these events happen, what will the community do? What will it look like when this fire is progressing through the landscape? And the questions we're interested in are, will they stay? You know, there's a lot of work and there's a lot of discussions ever since the Black Saturday fires about whether people stay or go. And the reality is people do both of those things. Will people wait and see? This is also a known behavior where people, when they're undecided, that they might decide to just see it out and delay their decision. Will they go and find shelter? And if they want to go and find shelter, where will they go? Or will they do something else, like go and find their loved ones? So when you tell people to leave, will they leave or will they do something else like that? And if they leave, what will that look like? Will the roads be passable? Or will their plans have to change when they leave? So these are all the questions that are in the forefront of your mind when you're thinking about these sort of situations. And the emergency services have to deal with these sort of questions all the time. So I'm going to say a little bit about how we're using AI and the work that we do in this group to help answer some of these questions. So fire prediction is one aspect of it, and this is something that the emergency services use heavily already. So here's a picture, this is in the Surf Coast Shire along the Great Ocean Road area of one of the fires that is projected to spread over the landscape. So you can get some sense of where the fire is and how it progresses over time. So where do we fit in? We take these fire progression models as an input, along with information about the road network in the area, and more importantly, information about the population in the area. Run it through some sort of an evacuation model, and I'll give you 2 examples of what that might be, and get some sort of metrics around what I'm calling evacuability. Some sort of understanding of what the risks might be. And different users will be interested in different kinds of answers here. So at the local level, for example, you may be interested in finding out congestions around key intersections or roundabouts. At the state level, you might be interested in finding out what the overall risk across a whole range of these events might be. Okay, so in trying to understand what the population or the community might do, there's at least 3 kinds of questions we want to answer. One is, well, who are they? And you can get this information in all kinds of ways. You can imagine there's information in the census, there's information in travel surveys that happen around the state, and you can get an understanding of what people do in these areas. So, for example, if a fire was to happen in a community at 12 p.m., where is everyone at 12 p.m.? Some of them are at work, some of them are on roads, and some of them are in shops. So we try and capture those things as well. But also from bushfire research, we know the kinds of things people do when they are faced with these situations. And so there's already this idea that you can put people in some sort of personas in terms of the kinds of things they will do. And just to give you some examples, some people might not even believe there is a threat, so they're labeled as threat deniers here. And others believe that someone should come and rescue them if there is a risk. And others are quite aware and they'll leave very, very early. So I mentioned that we want to model what they do. So when the fire hits the landscape, we already have an understanding of where people are in the landscape and what they're doing. And already in this exercise, we have to use different AI techniques. For example, optimization is used to get an understanding of what the activities of the population are and what the road network is like and how those two interact and what the traffic might already look like. And then we inject a fire into the landscape and we want to find out what they will do. And that's where all of this reasoning cognitive agents come into play. So we use previous research from bushfire and post-fire interviews and such to get an understanding of those behaviors, and then we try and model those personas in terms of what people will do. Here's a still image, and if you're interested in the videos, they're right at the back. I've got a demo there, so I can talk to you more about it there. But these are the kinds of outputs we'll produce. So this is a visualization. There's a yellow blob in the bottom, if you can make it out. That's the fire. And the green and the reds you're seeing is just traffic in the landscape. This is around the Great Ocean Road area as well. What you will see in these videos, if you come and have a look, you will also see people going towards the fire as compared to away from the fire. And that's because there's all these intermediate trips that happen. You know, people go in, if they have children, they will go and pick up the children, doesn't matter what you tell them. They'll be elderly and there's livestock, and horses are a big part of their lives. So all of these add to the extra trips that people make before they will evacuate. And these are all the considerations that add to the traffic situation. So we put all of this into play. And then the simulation gives you a sense of what things might look like, such as in terms of congestion times and evacuation times. And you can take the outputs of these simulations and aggregate them up into zones to give you a sense of what the overall picture is. And you can start to build these what-if kind of scenarios, and that's where the emergency services use these tools. So this is a still shot from the tool that we have, a web-based tool, and that's just contrasting the outcomes in 2 different situations. The colors here represent number of people in the zones, and the greens are where there's less people, the reds are where there's more people. And then the differences here are because of the actions that the emergency services took in those situations. So the way that they can use them is to help them contrast different scenarios and get an understanding of what might be a way to respond to these events. Okay, so that's just one fire, but we're actually interested in understanding the risk across the whole state. So here, I've just highlighted one of the fires, like the one I showed you before, but the colors you see in this picture, all these yellows and dots scattered around, are actually ignition points of fires across Victoria. So there's about 200,000 fires on this map, separated. They're lit every 2 square kilometers, and we try and get a sense of, well, for each of these fires, what's the evacuation risk or what's the community risk? And then you try and aggregate it up to get a sense of overall where the risks lie. So there's two ways in which we're using AI here. Here, this is a coarser model that tries to give you a best case optimized sort of answer. And what it's telling you is what's the fastest rate theoretically that you could move people from one area outside of the fire danger. And if that best case is already a bad outcome, then you know that reality is going to be a lot worse. Okay, so the two tools we have is one at this level where you try and understand hotspot areas around the state. And once you've identified these hotspot areas, you can then use the finer grained simulation tool that I showed you earlier to get a better sense of whether there is the risks or not. Okay, this is an example of the hotspots I just mentioned. So here I've just highlighted across a few 100,000 fires in a certain type of weather condition, which is an extreme weather condition, where, for example, the evacuation risks might be around the state. And again, this is trying to give the emergency services a sense of where the risks might be. Maybe you can see some patterns in where those risks might be, and then you can start to drill down in those areas and try and understand what exactly the issues could be. Okay, and that's everything I had to say. Please come and see me at the back there if you have more questions. Thank you.
Thank you, Dhirendra. And next, we're hearing from Associate Professor Julie Porteous about interactive storytelling.
We're waiting for some kind of a cliffhanger here. Well, as you said, my name's Julie Porteous, so when the slides appear, I will start talking about interactive storytelling, but the anticipation is killing. I'm going to talk a bit about interactive storytelling, and I've pulled out some topics of, okay, I've gone too far. Thank you. Okay, so what I wanted to talk about a bit today was interactive storytelling and some current interests, research interests that I thought might be of interest. I'm very much in this cognitive agents group, but as hopefully you'll see, it complements it, and it gives a flavour of quite how diverse the research in AI in the group is. So going back a bit to, it's like ancient history. So automated AI planning actually goes back to the early days of AI, really, and that the dream of some kind of a general problem solver. If you could, for any problem, if I could represent it in this particular language, I'd be able to solve it. And when I'm talking about AI planning, we're reasoning about generating plans of actions for agents. It could be a robot, it could be a software agent. And we have some initial state of a world, we have some goal state or some goal condition that we want to reach. And what we're facing then is actually a large search problem where we're trying to look through the possible combinations to find a plan of actions that will take me from my initial state to the goal state. It involves deliberation about goals, constraints, preferences, and it's from the early days, but it's right up to the present day as well. So you have these kinds of systems widely deployed in industry. So yeah, on the slide there, I've got Shaky back from the 70s, from the great-grandfather of all of this, but right up to date with things like the Mars rover, logistics delivery, planning is a feature of all of those. So theoretically difficult, still a lot of research questions, but still widely deployed. Interestingly, and I've been working in that area for a long time, but interestingly, the last 10 years or so, moved into the application of this technology into what I'm calling interactive media, interactive narrative, storytelling, new media, and games. It turns out the same kind of technology can be used for generating narrative, where narrative would be, if you like, the backbone of a plot, something in which we can scaffold a story around. That might be at the level of an overarching plot, or it might be to do with individual characters, agents in the sense that these guys have been talking about it. Yeah. And actually, planning turns out to be a great technology for this. It's really easy to generate loads of stories, and a lot of those are really rubbish. Yeah, so what we want to do is have some principled ways of being able to control the shape of these trajectories, the properties of our stories, you know, so that they stick with some, I don't know, desired aesthetic criteria or respond to a user in a particular way. And these are very much interactive systems, so users in the loop can change things, they can interact with the system and change the way in which the story can play out. So these have to be responsive interactive systems that can repair, regenerate the plan in the presence of user interaction. And these stories have to be told, presented to an audience. That could be through text, it could be through speech, but the framework that myself and a lot of the colleagues that I've worked with is to use the game engines. There's some examples up here. Worked in a few classics, reinventing, taking great liberties with Merchant Venice, Shakespeare, reimagining those, thinking about possible worlds, alternative ways in which these stories can play out. Yeah. Next slide. It's more than just narrative, as I think, you know, as I wasn't able to attend Fabio's talk, but things to do with interaction. We want human-computer interaction. People think of games and they think of consoles, or they think of mouse and menu. We're more interested in seamless interaction, so involving work with speech, gesture, gaze, which are controlling the way that a user interacts with a system, focusing on the particular part of the screen or the characters that they're most interested in and driving it in that way. Equally physiological responses, galvanic skin response, EMG, those automatic responses that people have to tension, excitement, comedy, and responding to those, and indeed some work involved with brain-computer interaction as well. And these kinds of systems in applications, it's powerful in games, right? Really powerful in games, so that you can deliver a cinematic experience which would play out, but you can interfere with, users are able to interfere with that. But also there's a lot of applications and systems that I've been involved with which have, one is in health literacy, and developing these systems. One here, I don't know if you can see it, but there's a lot of important requirements that people need to know about some kinds of cancer treatment to do with prostate cancer treatment, bariatric surgery treatment, and there's bars to that which are related to literacy, whereas these kinds of systems not only communicate the desired information to people, but have measures of how well they've understood it depending on how they interact with the systems. I better move on, I'm talking too much. So a few areas that I wanted to talk about current research, which still relates to that big picture of this planning, interactive storytelling. One thing that's of great interest to me and the others on the panel here is this idea of explainable AI, in particular explainable AI planning. With planning, we have a symbolic model which allows us the model of actions and action change in a world which allows us to generate the plans. But that also gives a really good level of granularity of abstractions about a domain to be able to communicate that with an audience. So one bit of work, in fact, these two bits of work on the slide here are with funding from the DSI. So one is looking at, the slide's not correct there, but anyway, diverse planning. So you know, a lot of this work could be aimed at generating the most efficient, the most cost-effective plan towards a goal. But it might be that there's a lot of a rich space of diverse, different possibilities, and there's a lot of issues to do with communicating that to people who are decision makers, so they're aware of the implications of those different plans before committing to one. Another thing that I've got shown on the visual here is to do with the idea of that in many situations there's that decision of whether to hand over, you know, interaction between a human and an autonomous agent or semi-autonomous agent, when to let them get on with what they're doing and when the human needs to intervene. And there's a really, really important job there of communicating upfront the implications of different plans. I don't know if you can see it, but the radial graph on the left-hand side is a space of different possibilities of a way in which a plan could act out. Too many to communicate to a user, but what is that human decision maker? What do they do to decide the implications of that large space of plans? So we've worked on ways of clustering some of those and extracting, characterizing traces, the most different N of those, a small number that can be communicated to a user so that they can get a grasp of the space of possibilities and the implications of that. So that's one area of current work. Another is related to AI planning. And one thing that's particularly of interest to me is when you've got a space of diverse plans, different options, how do you see what your user is interested in? It's this joint work with Mini, who was the first talk up this morning, actually, and that idea of, we want to be able to ask users or find out from users in some very low cognitive burden way, do you prefer A or do you prefer B? But also added into that is that you need to give them a very small part of a plan to be able to make that decision from, because it just, cognitive overload. So we're looking at developing a preference elicitation framework where we can learn the preferences from small instances, from small plans, and then generalize them to large plans. So that's one area of work. Another is this idea of needing to create a symbolic model to generate plans. That's expensive. If it's narrative, there's a lot of authoring time involved in that. If it's any of these kinds of systems, these have to be engineered. So what interests me, and I've had some success with the work, is learning these domain models, and possibly in a semi-interactive way with the user in the loop. What's meant to be shown there is on the left-hand side, you have some kind of input, could be stories, could be real-world observations. You've got some black box handle turning in the middle. What's different to some of these machine learning talks that you've heard earlier is that the output, the target that we're interested in, isn't classification, yes, 0.68. What we're interested in is producing this generative model, which we can generalize to other domains. And very quickly, the last thing that I wanted to say, and probably the most important given the aging people on the stage, is narrative or extracting certain patterns of interest from large agent simulations. So one bit of work funded with the DST group and in working with John and a PhD student is looking at large simulations, or indeed they could be games, for example, this one that I put up here in motivation, extracting information about the interactions between agents in that system, how it affects their fortunes, and recognizing patterns of shapes of interest. That might be stories of interest. I think I'm out of time now. Anyway, thank you very much. If anybody's interested in any of this, happy to talk about it later. Thank you.
Thank you, Julie. And that concludes the session on agent-based decision-making. And now we're getting to a very interesting panel. AI isn't just about technology. It's also about how we use it in an ethical and good way. Can I ask the panel to please come up? And I'll leave it to Lisa to introduce your panelists.
Thank you. I think we're live, right?
Particular order?
No. Thank you, Lisa.
Rita.
Pleasure.
What an interesting set of topics today. Thanks everyone for being here. And this particular panel is here to discuss the question of AI and ethics. My name is Lisa Dethridge. I am across the School of Design and the School of Media and Communication. I'll be asking my fellow panel members to introduce themselves so that we can get all the information straight. There are a couple of questions that I have about the logic of putting the words AI and ethics in the same sentence. The first question that I have, concerns the fact that in the 21st century, at this point, we are a species who have come to a number of disruptive realizations about ourselves. For example, we are a species who have spoiled our own nest. And I'm not sure there are many other species who are guilty of this. And so at this point, can we actually project our superior intelligence onto a technology and accept that it may actually be a fail-safe thing? In other words, how smart are we really? And therefore, how smart will the machines be that we attempt to invest with our great intelligence? Should we perhaps be putting a pause on the notion of artificial intelligence and calling it something else, such as perhaps augmented humanity or assisted, I like this notion of teamwork that the previous panel was insisting upon, that we team up with the machines rather than situate ourselves in a position of dominance over the machines for fear that the machines will then become our overlords. I don't know, perhaps you folks are ready to bow to the machine overlords. Perhaps you're ready to line up for the implants. I'm not sure I am. So that is my question for the panel today. I know it's broad, but does it even make sense? Are we being too hubristic? Are we flying too close to the sun to even assume that the tools we currently call AI are actually much more intelligent currently than a cockroach? So to help me answer this difficult question, I have some colleagues, and I'd like to start with Matt Sinclair from Microsoft.
Hello everyone, my name is Matt and I welcome our robot overlords. No, I'm from Microsoft. I'm Microsoft's Global Director for AI Sales and Strategy. So I'm based out of Melbourne, but work out of our corporate office and responsible for making Microsoft and our customers successful with AI, of which responsible AI is a very big component of that conversation.
Thanks, Matt. I'd also now like to go to Justine Lacey, who's our special guest in from CSIRO Future Science Platform. Justine.
Okay, thank you, Lisa, and hi everyone. So I am Justine and I am from the CSIRO and I am from Brisbane as well, which might be a bit special today. And what my job is at the CSIRO is to build up a new, what we would call emerging science area called responsible innovation.
Responsible innovation. Excellent term. Thanks, Justine. And Marta Poblet-Balcel from RMIT. Professor.
Thanks, Lisa. Hi, everyone. I'm Marta Poblet. I'm a professor in law and technology here at the Graduate School of Business and Law. Obviously, AI is one of the most consequential technologies, very relevant for lawyers, for policymakers. So I like to work at the intersection between law and policy and technology and responsible innovation as well.
Thanks, Marta. And of course, Rita Arrigo, who is Deputy Director of the CIAIRI Centre for AI Research here at RMIT, who's our very gracious hostess today.
Thank you. And it has been amazing to have everyone join us here today. And I'm new to RMIT and new to academia, having spent years in industry. But what I'm really passionate about in my role is to make adoption of AI easier, because I think there's so much we can solve. I'm the opposite of Lisa. I'm a pro AI, so we're going to try and help demystify that a little about how responsible AI can actually solve some very complex problems, and I'm really very passionate about that.
Okay, so how can AI? We do understand, of course, I'm not anti-AI at all. We understand that the fabulous applications are currently most visible in healthcare, engineering, infrastructure, disaster management, the kinds of examples we've seen here today. But there is this nagging suspicion that there's a kind of folly or a sort of a sense of delusion in many humans, not you people, of course, but many humans have a slightly delusional nature where, for example, at the moment, we haven't been able to tell the difference between what's real and what's fake in a number of contexts. Do we need a sort of a framework, a set of guidelines, or a governance or legislative framework to help us through this thicket of human confusion? Justine.
Okay, well, maybe I'll start by explaining a little bit about what, when I say responsible innovation, I mean when I'm working at CSIRO. So we have a set of future science platforms, and it's about, I think, $200 million of research into really strategic, future-facing science and technology development. So because we love acronyms, we would call it the VUCA science. So it's volatile, it's uncertain, it's complex, ambiguous. So these are portfolios of science where we intend to be disruptive, and we need to be honest as scientists and researchers that we do intend to create disruption. We just hope it's the kind of disruption we intend. And so my job was to come along and look at some of the social and/or ethical risks or implications of that portfolio, and it's diverse. And so there's 20 of those future science platforms, and they're different. And it's on the internet, it's all in the public domain. But I kind of cut it into 3 portfolios where I say to my science council, here is where you really need to be across responsible innovation. It probably looks like socially responsive genetic technologies, and that's really different. It looks like the stuff we're doing to create environmental scale change, either at landscape, regional or climate scales. And it also looks like emerging digital tech. And AI could eat the whole budget in that space, but it's quantum and it's data and it's everything digital. And I'm doing a lot of work with excellent colleagues. And one thing that I've noticed is that in my data science engagement, they prefer the word responsible to the word ethics.
Why is that? What's the difference between being ethical and being responsible, I wonder?
I'd say it's intriguing, but ultimately, if you look at the tradition, the philosophical tradition, there is not much of a distinction between the two, because consider, for example, a philosopher such as Emmanuel Levinas, who, by the way, predates the AI era, because it was 20th century, first half, for whom every ethic is ultimately responsibility. So the first philosophy is an ethics, and his ethics is an ethics of responsibility, which is a very strong term, by the way. So in a way, we can rename it as a responsible AI, but the ethical component will be there anyway, because it's the same philosophical tradition.
We found a slightly different message. So ethics, subjective, depending on the person, the culture, religion. Ethics is up for discussion. Sometimes it shouldn't be, but it is. And so we found ethics to be quite an ambiguous term. What is ethical AI? So we've pivoted to responsible AI as being our core message, because you can argue whether something's ethical or not, but it's much easier to say whether you're being responsible in your practices with AI. Are you taking accountability for the decisions that your machine learning model is making? Are you taking responsibility within your organization to be accountable for the outcomes of your AI? And so we've pivoted our strategy quite substantially to still including ethics, of course, as part of the conversation. But when we speak to executives and organizations, we found responsible resonated far better and was more measurable, more attainable than ethical, which seemed to be this asymptotic goal that we couldn't quite obtain. So slightly different pivot as we're looking at the technology side of things.
That's interesting, Matt. Do you think it has anything to do with ownership of the tech and or ownership of the data?
Yeah, 100%. And we often don't just talk about responsible AI, we talk about responsible use of data as well, because it's all the same conversation. But what's interesting when you talk about responsible AI is it's exactly as you say, Lisa, it's not just the governance and processes and people that you put in place, but it's most importantly the tools as well. So how do you embed responsible AI practices into your Jupyter notebook if you're a data scientist, or into your CI/CD pipeline if you're a developer? Well, how do you have these tangible responsible AI checkpoints as part of the technology?
Checkpoints as part of the process when we're embedding the tech into an organization or a system.
Yeah, exactly right. And not to tell us whether we're being responsible or ethical, because then you get in a bit of a circular loop where you're relying on the AI to tell you if you're responsible or ethical, and how do you trust that AI, and you end up going forever in a loop. But instead to give us the information so we can better make decisions as an organisation. So we don't, it's nearly impossible to completely remove unethical AI or bias, but what we can do is institute mitigative circumstances or mitigative processes. And that's where this technology comes into play. It gives us the information that we need to see deeper into the decision-making process, which then in turn allows us to be responsible about the decisions we make with AI.
Interesting. Marta, you're a specialist in the law. Are there any particular examples you would guide us towards in the use of ethical or responsible AI? Are there any frameworks that we should be looking at?
Well, as you mentioned, the ethics and the law are deeply intertwined. So for the past few years, there's been I would say even a Cambrian explosion of documents covering AI and ethics. Some papers have counted more than 80 documents across the different world areas. Obviously, because Europe has always this very particular approach to regulation. There was last year the publication, almost a year ago, 21st of April, I think, the new proposal for an AI Act. That's going to take a long time to discuss, it has to go through Parliament, the Commission, and so on. But it was preceded by a large public consultation process, where more than 1,200 contributions were collected to come up with this proposal. Then in a way mimics a bit the same, the very same risk-based approach that was adopted with privacy and data. So the proposal distinguishes between prohibited AI systems, high-risk AI systems, and other than high-risk systems, and applies different regulatory frameworks to the three of them, ranging from a very strict management plan for high-risk systems, meaning those who affect health and safety of individuals or fundamental rights, to a more self-regulatory approach where codes of conduct are encouraged, and that's for low-risk systems. So likewise with privacy, there is this Brussels effect where every regulation that comes from the European Commission aims at having a broader scope beyond the European frontiers. So that's a bit the approach that they are adopting as well with the AI Act. But other jurisdictions obviously are developing their own legal frameworks. I think it was also last year that the US was discussing an AI Bill of Rights, and we can expect more of this happening in India, China.
An AI Bill of Rights?
Yeah.
Yes, would that be a Bill of Rights to protect our robots, such as the beautiful robot that's been stomping around today that I nearly hit with my umbrella, so much for its rights. No, seriously, that robot's very interesting because it's currently being used in Victorian hospitals. So back to the idea of Bill of Rights and who should it apply to. Rita, as an electronics engineer yourself, have you ever found any outstanding obstacles? What do you feel are the obstacles when you're attempting to design in AI frameworks with corporations and organisations? What are the stumbling blocks in the ethics department?
I think there's some major challenges around data ownership and data and collecting data, and then also being able to have the ability to create autonomous systems and having that multidisciplinary challenge that I think we have a lot of those challenges where you need to bring the lawyers in and you need to bring the philosophers in and be able to actually have those debates and discussions. And I think that's why, being able to everyone to learn a bit more about AI helps the multidisciplinary areas. And I thought it was really interesting when you were talking, Justine, about genetics and some of the challenges in that space.
Well, earlier, I'm still stuck on this idea. I do know why people prefer to say responsible to ethical. It's a fear factor, right? because ethics feels like you can't control it. It's going to get away. It's going to stop the conversation. It's going to stop the tech. And where will we be? We'll be here arguing and arguing and arguing, right? So that's why. But I challenge you this. When you say responsible, do you mean backward looking or forward looking? Because they're different, right? And I'm ripping off a really great Dutch ethicist right now. Because if it's backward looking, it's about accountability, liability, and blameworthiness. It's about when everything goes wrong, where will we put the blame? Who will we hold to account? And getting that in our control, we feel like we can. But if we're doing a forward-looking responsibility, that's a different kind of question when it comes to tech. This is about, you know, the AI for social good. Are we trying to create some sort of different new benefit, or do we just want a really good accountability framework around what we're doing? Now, both of those things are ethics, right? But the outcomes are going to be super different. And so I still want to play with that language. I realise I'm being that person doing semantics, but I think when you say responsible, what do you mean? And what are you accountable for? Or what are you trying to create? And what are you going to hold yourself to account for whether you do or don't create it? Do you still want me to talk about genetics?
Well, yeah, because I think it's really fascinating that you talk about, you know, AI for social good and how at the moment we are kind of stuck in this blame cycle, I suppose, and a risk management approach, which it doesn't really allow us to address, you know, why are we actually doing this? And like, what is the reason why, you know, we want to create a better environment, or why do we want to, like, so to change that side of things. So I wanted to explore a bit more, like, the kind of complexity associated with, you know, if we could manage our genetics, like what would that mean, and how could that, you know, what are some of the challenges we need to address through that process?
Designer babies.
Designer babies. We actually asked Matt if he would give himself a designer baby.
Oh. Yeah, the answer is I'd consider it, but I'm maybe a future forward looking person.
Do you think this is generational, Matt?
Yes.
We love having young folks like Matt on the panel. Of course, we all just want to push forward you young people and put you in charge as soon as possible, but you've got to sort out this question first. So the question of, for example, designer genetics and so on, what do you think, Matt, in your experience, and you've had very broad experience across healthcare, ag tech, what do you think of the stumbling blocks and the opportunities here for ethical discussion?
Yeah, well, I'll touch on the generational component, and then we'll throw back to the genetics time, because I think you had an interesting point before, like earlier today as well. But for me, one of the biggest things with responsible AI and genetics and all of this concept of data is it's absolutely a generational shift, right? Like, I think about my parents and their awareness of data on social media and what they do versus me, versus the younger people that I interact with as well. And I look young, but I'm maybe not as young as many of you may think. And so there is this huge generational shift in how we use data, how we accept AI. And I think that has a bigger part to play that we haven't quite explored yet as a society, because we're still in this mixture of generations where we're not quite comfortable with technology, or we're coming to terms with technology. But project forward 20, 30 years where everyone has accepted all cookies on every website, everyone's posted all of their data to all of their respective social media sites. I think you'll find there's more comfort in data sharing. But at the same time, maybe we have the inverse. So maybe we have everyone try and pull back their data. And I think one of the points earlier today was around, what was it, self-sovereigning data, which is an interesting concept. So for me, it could go either way, but I think the generational shift is something that shouldn't be forgotten about. And what we're building today in terms of responsible policies and responsible AI technologies absolutely has to be able to adapt to that generational shift as well.
Do you think there's a possibility then that in future I may be able to exploit my own data for my personal financial gain? This idea of sort of reeling back my data, owning it, and being able to sell it to various entities, is that possible?
Well, I think so, but do you want to touch on the sovereign data stuff you were speaking about earlier?
Okay, so this is related to a real project that I was talking about with the colleagues earlier, and many of you will know Dennis Bauer. And so Dennis Bauer runs our transformational bioinformatics program at CSIRO, and what we've been doing around responsible innovation, and I actually think you can identify ethical risks, like in an evidence-based way. So what we've been doing is we've been interviewing people who do research, what I would say back-end people who work in bioinformatics, people who are clinical geneticists, and people who do genetic counselling. So all along that kind of sort of clinical genetics value chain, if you like, or the professional value chain. And what we find when we talk to them about what is risk and what is benefit is that those very different, four stakeholders, professional stakeholders, they all agree on the benefit of clinical genetics. It's to get better patient outcomes, better treatment across the board. When you start to ask them about risk, so diverse, right? And it really starts to diverge depending on how close or far away you are from the patient. Questions about privacy, they agree on as the top risk. And that starts to say, well, will we ever have a nationally federated genetic database in Australia? We don't have one now. There's a whole lot of governance issues around why we don't have one now. And Dennis is really interested in jumping across dynamic consent and saying, would we ever have self-sovereign data identity? Would you ever own your own data, control how it's used and manage how it's used? And the conversations we have with the professional stakeholders there are very, very interesting. And their timelines and whether they think it could ever be real are also highly variable.
What's interesting is on that point of like self-governing data ownership, there's actually a whole work stream we're working on at the moment where how do you still perform AI activities whilst having completely confidential and encrypted data as well. So I think there's an intermediary step between clawing back the data and having the self-governing versus how do we just make sure that when we share the data and people build their ML models off the back of it, that it's protected. So how do you train a machine learning model on health data without ever seeing the data? That's pretty tough, but it's possible. Complex at the moment, maybe not as scaled as we'd want, but certainly there's ways to perform these mathematical actions without ever seeing the data inside, because instead we're looking at the statistical trends of the data. And so I think that's a huge step before we get to self-governing data, which I think is a further step away.
It's a long game. Yeah. It's a long game question. But it allows that kind of exploration. What is the social risk in that situation? What's an ethical risk? Everyone agrees about privacy. But the way risk falls for patients in that system, for families in that system, and the debates around who actually owns it. So people in labs actually say, well, we kind of run the data, we create the data, we just get tissue, right? So maybe we own it. So there's some interesting questions about ownership already happening about genetic data in Australia, just based on how people treat it as it's moving through different workflows.
I suspect there may be some people in this room who could help us with further answers, but for the moment I'd like to open the room to questions from the floor. Does anybody have any questions for any of the panel on these discussions? You could perhaps
scary question.
Have a think. Deep, scary questions indeed. Yes. At what point might we consider AI as superior to ourselves in tackling problems? And is that even a responsible viewpoint in the first place? Does that capture your question? Yeah. That is the deep, scary question. That's the singularity question, isn't it? Are we approaching singularity? Who'd like to tackle it?
Well, quick qualify, because superiority is a really interesting term to use, because superiority in what way? Like superiority in terms of singularity, super intelligence, artificial general intelligence. Are we just talking about superiority in terms of the ability to quickly, accurately, and appropriately gather the right information to respond to questions in a way that humans can't even bother to answer? Because right now, there are AI models that do that very well. They're not intelligent. I wouldn't consider them superior to human intelligence, but gosh, their ability to pour through, I was telling the panel earlier, we work with a pharmaceutical company who pour through tens of thousands of research papers in a couple of minutes to tell researchers where they should be investigating for potential pharmaceuticals to address medical needs. Used to take them years to pour through this data. They can do it in minutes. That's technically a level of superiority. So there are elements where AI is already today far superior than we are. But if you're talking about superiority in terms of the singularity or general intelligence, I think we're a bit further away from that than we may think.
Yeah, I completely agree. And maybe going back to the term artificial intelligence, let's remember that was a term used in the Dartmouth conference of '56 by not to get in trouble with cybernetics. So they wanted to ask for funding and they wanted to detach themselves from the cybernetic research that was developing at that time. So it's relatively easy, perhaps thinking about what is artificial, but what is intelligence is a completely different story. So it depends on the context, it depends on the area. And I would say that you may like this, that we need a fractal approach to intelligence because it depends on the scale, it depends on the particular area we are looking at.
A fractal approach to intelligence, did you say?
Yeah,
Marta?
Because I'm thinking in terms of governance as well.
Yeah.
Fractal governance has been one of the models that could potentially be applicable. We've been talking about fractal governance in the blockchain area for some time now. I wonder whether this could be translatable to the governance of artificial intelligence, because it's such an umbrella term, artificial intelligence. What do we mean? Do we mean machine learning algorithms? Do we mean symbolic AI? What, robotics?
Yes.
And do we need the same governance system for every of those technologies?
Yeah.
I'm not sure. Probably we need a more nuanced approach to governance, and that's where fractal governance comes into play.
Okay, we need a more nuanced approach, a more nuanced set of definitions around intelligence, around what is real, what is artificial. In general, we seem to be bringing a heightened state of awareness to our own humanity, and that can only be good, unless we fall into pointless navel gazing. Any other questions? Great question, thanks. Yes, Hernan, hi.
Hi, first of all, thanks for the reflection on responsibility. I think that was very insightful. And I wanted to ask you about another term that I commonly encounter when talking about ethics and AI, which is fairness, the notion of how machine learning and artificial intelligence is affecting different populations in different ways. And I wanted to ask you, in your experience, because I found really interesting how each one of you was talking about different experiences that you've had when addressing the issue of responsibility in the different contexts and in the different words. How have you encountered the notion of fairness, and how are different people and researchers addressing the idea of equitable design and equitable product development in regards to artificial intelligence?
Great question, thanks Hernan. In our experience, how can we address the question of equity? Now, Rita, I know when you were at Microsoft, you worked on some amazing projects, especially those in relation to disability, inclusion, blindness, the use of AI in different contexts.
And I think you're relating to equity not just from a financial perspective, but also from an abilities perspective. And I know, having been spoilt with the huge investment that Microsoft had made in inclusion, and particularly to use AI to make it easier for people of all abilities to be able to be part of society. And I think it was quite incredible, some of the initiatives around computer vision, around navigation, around being able to read text and use language processing to be able to make that text so much more valuable to people in no matter what ability that they had. And with the mixed reality, there was also lots of work being done around that, around allowing people to understand people's emotions that are around them and connect them better in that space. So I think it's a really exciting area for inclusion with people with a range of abilities, and as well, not just if you have a permanent ability, but also sometimes people have that in a non-permanent way. It might be you broke your leg or different things. To be able to bring that accessibility into the world with AI is super exciting. So there's lots of work going on in that space. But when I think about equity as well, I also think about, what do we do? And Lisa started talking about, what have we done to our earth and sustainability? And I think that's an area where responsible AI can really pick it up a lot and be able to start to think about, what are we doing with sustainability? And I think the panel has a lot to say in that space as well. And I'd like to get them to share. But did you want to share, Matt, like the kind of things that have been achieved through being able to focus on sustainability as a goal and how AI can actually address some of those things?
Yeah, sure. I'll be brief because I answered the previous question first. I want to give others a chance to speak. But so on sustainability and fairness, yes, so we're seeing most organizations are actually trying to use AI for ESG purposes. So trying to attain a better understanding of their enterprise and sustainable outcomes for their organization. So heaps of work in that space because AI helps us make sense of the data that is too hard to process by humans, right? So huge use case for AI. But specifically on the question of fairness, on how we enable fairness in the process. Fairness is one of 3 pillars for responsible AI for us from a technology perspective. Fairness, explainability, and interpretability. How do you explain what happened in the model? How do you interpret that in terms of how the model made a decision? And then how do you ensure that the model has made a fair decision by doing what-if scenarios and being able to see in a particular decision from the model what was the data point that influenced the model most? And was that a sensitive data point, like maybe gender or postcode or something like that, or was it a more neutral data point? So in terms of fairness, the technology is definitely one key component, and we're open sourcing all of the technology around fairness and explainability and interpretability because we think it should be everywhere, not something that you have to purchase. Fairness is also in the processes around the organization as well. So it's all well and good to have explainability, interpretability, and fairness built into the tools, but what happens when something is unfair? Who makes the call? Is it the data scientist? Is it Microsoft because we made the tool? Is it the consumer gets to decide that it's not fair? And this is the thing that's sort of wrangling through the tech world at the moment is what does fairness mean and who actually owns that fairness decision beyond, in the code? And not to waffle because I'll pass back to the team in a second, but from Microsoft's standpoint, we take fairness very seriously. So with all of our AI tools, we actually go through quite a rigorous process from a technical people and process perspective to ensure that we're as fair as possible. Great example is we won a facial recognition contract out of LA, where we were going to use facial recognition technology to scan people who were in the backseat of a cop car. Maybe you can hypothesize on some of the challenges of trying to facial recognize people in the back of a cop car and identify whether they had criminal records or not. But let's just say that the data set wasn't there. It wasn't diverse enough to be able to make fair decisions about whether that person had a criminal record or not. So we actually won it. It was a several $100 million deal. We turned it down because we felt that we couldn't be accountable for the decisions because we didn't trust our technology to make the right, fair decision. So we turned it down. Another technology picked it up, no stress, cool, $700 odd million in their pocket, but for us, it was too much of a burden to bear, and we couldn't put that out there and know that our technology wasn't being fair. So fairness in particular, technology, people within the organization, but also companies producing the technology as well, key part there along all 3. So that's my view on the fairness angle, but others may have different opinion.
And then you go, Marta. Because Matt just said something really interesting, right? Microsoft made an ethical decision about taking that contract or not, and it's not controversial for me to say that, but they kind of assessed it and they were like, this doesn't fit with our values and we're a little bit concerned about this. And it's not shocking that that's an ethical decision that the company makes, right? And I think a lot of decisions have an ethical component, but I had to say, I love that you ask about fairness because that's one of, it's obviously in all the frameworks, fairness comes up over and over again. And many of my colleagues will go, oh, this one's so contextual, it's hard to write an algorithm around this because you can't do it out of context, right? context absolutely matters for this one. And I've been researching what the Australian public thinks about lots of different things for the past 10 years. And apparently what we care tons about is fairness. And it comes up in all kinds of research. And that could be a particular cultural thing about us. We like to know, we can have a say, we don't always want to activate it. But there's that procedural fairness, but also distributional fairness, where the risks and benefits fall on people as a result of what we're calling now fair. Who's impacted, you know, for the better, for the worse? Do we all consider that's a fair kind of distribution of those impacts? And even interactive fairness. So I think fairness is actually way more complex in kind of the reality of turning that from an algorithm into something. And you just can't do that one out of context. Like a universal fairness, that would be worth $700 million, right? But I'm just not convinced that it's there. I think there are ranges, not a universal though.
Just to confirm that finding, in the documents I was mentioning before about so many legal principles being, ethical principles being developed for AI, one of the most frequent in all these documents is fairness again. So it's an overarching principle that every ethical and regulatory framework wants to take into account. And going back a bit to your question, who gets to monitor the fairness of algorithms of AI systems, let me rant a bit about the European draft proposal, because even though it collects a lot of public sentiment around what principles should be enshrined in that legislation and so on, then somehow this crowdsourcing method is lost, because when it comes again to governance, it's a very top-down system where the European Commission will have a European AI board composed of national authorities that will act as a monitor of the market and post-market systems. And I wonder why this is happening, why we are losing the input from citizens and the crowd in the most important part of the process, which is monitoring how these systems work in the markets, whether the data sets need to be retrained because they are not fair enough in how they behave and fit the algorithms. So in a way, fairness is a distributed sentiment that should be somehow embedded in the monitoring of the AI systems. But that part is lost in my opinion.
So you're suggesting that we need a distributed system of responsibility where community groups would also buy in and have to take responsibility, certainly, instead of just projecting all of the responsibility onto a government agency.
Yes.
Say the communities need to get active and become more responsible, perhaps. That's a really interesting viewpoint. Justine, you've had a lot of experience with public consultation around AI and ethics, and I believe right now you're actually doing a consultation with the World Economic Forum. No booze and hissing from the audience, please. That you're doing quite a large consultation with World Economic Forum. What kind of groups tend to be popping up and putting in their 10 cents worth in these consultations?
Okay, probably I would say I've done less public consultation on technologies overall. I've done them on industries, particular kinds of land uses and things that you can notice when you're out in the world that maybe change the place you work or live, really kind of physical changes in the landscape. But we have been doing work with the World Economic Forum, and that's largely been about developing governance guidelines for quantum computing. And so they launched those in January this year, so they're the first kind of large organisation to put out a set of governance guidelines for quantum computing. And some of the questions they had, because they were working on it the whole 12 months prior, and they collected stakeholders, and CSIRO is just one of them, from around the world, to help them craft up what these governance guidelines would look like. And one of the challenges they felt they needed to overcome was that a lot of the AI ethics frameworks were great high principle, high concept stuff, but kind of insufficient for actually kind of operationalising, and sort of, you know, like 5 to 10 years later, you're still having a breakthrough if you can operationalise a principle with AI. And they really wanted to say, how do we make this a much more action-oriented approach? And so at the moment, they're having conversations with I think both countries and companies about, I think IBM was one of the companies they were talking to. They have been talking to Australia about saying, well, if we come up with these governance guidelines for quantum, are they any good? Would you use them? And if you did use them, did they change anything for you? So I'm kind of interested in the fact that they're willing to kind of say, here we go, we've put these together, but are they going to be useful? And if they're not, what should we be changing pretty quickly?
Are you seeing much directional shift now as the conversation branches out to include quantum computing, blockchain, and so on? Is that shifting the sands, or do the questions remain the same, despite the fact that the techniques under discussion are changing every day? Does the substrate of the ethical question remain the same?
I mean, I'm just coming to grips with quantum anything at the moment. So, and I will just say that because people will hold up juggling balls and try to tell me about superposition, but I'm still coming to terms with it.
Quantum means very fast computing, doesn't it, folks? Where are the experts? Where's John Thangarang?
But I'm intrigued by the thought that I've heard over and over in this community that they're like, oh, ethics and quantum is going to be like AI ethics, but like just exponential. And there's this idea that, oh, we haven't figured that out with AI yet. So what's going to happen if this one gets away and gets off the chain? Now, I don't know how true that is, or if that's just the kind of the narrative around this current discussion. But in terms of ethics, they've started more with governance as a way of organising the conversation, which might be about controlling that fear factor and, you know, what does it mean? And it'll shut everything down. And, but quantum to me in Australia right now feels like Bitcoin, the Bitcoin of science. It's like everywhere, like there's a new thing popping up every which way. And I think it's actually quite stressful for some of the researchers who've been kind of grinding away for 20 years and suddenly everyone's at the window looking in the fishbowl. And we've got the national quantum strategy being developed and lots of activity around quantum. So it's in a real kind of shift space at the moment.
Yes, indeed. We're all on the ever increasing learning curve. Any other questions from the floor? Yes, please.
Go, Troy.
And that's where there's another solution space that we go to, let's say, for about 20 years from now, generation differences. People might accept the idea of replacing governance with AI, so that there's a frame currency. So it's not out of the question. But to bring all that back into a question, I guess, how would you reframe some of your thinking around that question? Not after thinking myself, on a more flat about 20% range.
You're asking me to embrace my inner AI, Troy.
Yeah. All right. You're going to take it on, Matt. Go.
Well, and so one of the analogies that we use with AI is because people talk about losing their jobs to AI all the time, right? So it's displacing of the workforce, really big conversation. And the way I like to frame that conversation with people is the horse lost its job to the car, right? But the car created jobs, the car just made humans more efficient, more effective. It allowed us to scale, pull more, pull more stock than a horse possibly could. And yes, some horses had to retire, and some people lost their jobs that were reskilled, etc. So for me, AI is that accelerant of humans at the moment, even in the short term. I know you're like trying to project it to post-human as a frame of reference, but for me, we haven't even hit that sweet spot where AI and humans commingle and really complement each other. Like at the moment, I want to throw my Google Home across the room 9 times out of 10, but I just imagine what it's like when that is a seamless interaction, the seamless experience. It does get the information I want. It is advanced enough. We talked about before about superiority. It hits some of those superiority characteristics. And for me, that's when we're really going to start to see the benefits of AI and human. But I think I heard someone equate AI to a more advanced form of pen and paper, like it should extend the human ability. And that's the kind of sweet spot rather than this humans owning AI or AI becoming overlords or anything like that. How do we make an extension of ourselves? We're definitely not there now, but we're definitely seeing components of it. And for me, the most successful AI implementations I've seen are when humans are still in the loop. And it means that humans can do the more creative jobs and the humans can do the more bland manual jobs, and by exception raise items to humans. That's where we're really going to start to see the huge productivity of AI that we're kind of all wishing and promising.
Beautiful. So you're talking about a sweet spot where there's a human in the loop and has achieved a great balance with their AI assistant, their augmented self. Thanks very much. Thank you to the panel. We've reached the end of this segment, and now it's time to toast our AI augmented selves with an espresso martini from the bar.
We're going to have one session first. We're going to invite Omniverse.
Oh, that's right, the Omniverse. First, we get to visit the Omniverse.
So just before we break for our alcoholic beverages, the coffee car's just closed. I want to introduce and welcome Gary Mancuso to give the final talk of today, where he's going to tell us about how we can, how we can enter ourselves or immerse ourselves into the Omniverse, and then we can all indulge in a beverage sponsored by Nvidia. Thanks, Gary.
Well, that's not a good start. Hey, thanks everyone. Okay, so I'm Gary from Nvidia. Pleasure to be here today. I want to thank our partners Xenon and Dell, both great partners of ours here in Australia and New Zealand, for their assistance here today. Special thanks to David Soroki from Dell, who I understand mentioned Nvidia in his presentation much more than he mentioned even Dell, so I owe you, thank you very much. And he's made, from what I hear, a great presentation, so he's made my life a little bit more difficult because it's a tough act to follow. I'm also cognizant that I'm between you and drinks, so this is not going to take the full half hour. I certainly don't want to be the person that has footprints on his back as you rush to the bar. This presentation will be brief. There'll be 2 or 3 videos that we might watch, and given that we do have some time, I might actually play an optional one at the end. But without further ado, let's talk about Nvidia's Omniverse and digital twins. Okay, that worked, that's great. Okay, so what is Omniverse? Omniverse is not the metaverse, which you've probably heard the term metaverse bandied around lately. Metaverse is it's a concept of connected virtual worlds, an extension of physical and virtual worlds. I think metaverse is like virtual or augmented reality, and perhaps with the primary scope of entertainment. Whatever Facebook has planned for this metaverse, that's their business. But Nvidia, we view the metaverse from more of an industrial and engineering perspective. So the idea behind Omniverse is to have 3D worlds that will usher in a new era of design and simulation. It's software by Nvidia. It is both a design collaboration tool and a scalable 3D simulation platform. It could be that to create a metaverse, you might use Omniverse as your tool. Importantly, Omniverse obeys the laws of physics, so you can simulate reality, gravity, wind, light, and shadows, so that you can make realistic digital twins of practically anything. Central to Omniverse is the USD file format, which it stands for Universal Scene Descriptor, and it was something that was developed by Pixar. It's an interchangeable file format, which did a lot to overcome file format challenges when sharing files and models between different design tools and software. We took that and expanded it to allow simultaneous collaboration in much the same way that Google Docs or Microsoft 365 allows multiple people to edit a document. That's what we can do with Omniverse. So why don't we watch an example video and I'll show you what Omniverse is capable of doing. I'm not sure if I have to hit this button twice.
In this collaborative demonstration, we're seeing 4 different artists and engineers using Autodesk 3ds Max, Autodesk Revit, Adobe Substance Painter, and multiple instances of Omniverse View. The live sync between these applications is being maintained by the Omniverse Nucleus server. In this demo, we have Jay, Ashley, Kevin, and Dave all collaborating from different locations. Let's take a look at how these artists are leveraging the Omniverse collaboration platform. Kevin, in the bottom left, is loading the landscape from 3ds Max and aligns it to the Revit building. Dave, in the bottom right, adds windows on the building in Revit with instant results in Omniverse View. Jay, in the upper left, adds the auditorium interior variants using 3ds Max. While Jay in the upper left toggles ceiling dome variants in 3ds Max, Dave is testing results by changing the time of day. Dave in the lower right toggles flooring variants, while Jay connects his interior decoration 3ds Max scene to the stage. Jay in the upper left in 3ds Max is adjusting the artwork position. Ashley, seen in the upper right, is adding indoor plants using Omniverse View. On the upper and lower right-hand side, both Dave and Ashley are painting vegetation simultaneously from their own Omniverse View instances. Dave loads in the cityscape in the bottom right and places it around the building, while Ashley in the upper right is still working on the landscaping. Kevin in the lower left can be seen adjusting the time of day. Dave in the lower right is working on the landscape. He's assigning new materials like the water surface, and then adjusting the time of day. Ashley in the upper right adds a centerpiece in 3ds Max and a chandelier. Dave in the lower right adjusts the time of day and his camera. He's exploring creative options, while Ashley in the upper right is in Adobe Substance Painter editing the art pieces. So in this demonstration, you see how 4 creatives can collaborate and really explore possibilities in context, modify CAD files, inserting thousands of polygons worth of foliage, interactively changing the time of day, and all of this while never having to do a single test render.
Okay. All right. So basically, the next part of Omniverse is the digital twin concept, and so what you just saw was a digital twin of the proposed building that all the designers were collaborating on. So it's what is a digital twin? It's supposed to be a virtual replica of a physical thing, identical in every way. It's physically accurate, it's three-dimensional, it's a three-dimensional model, and imitates the behavior in every way of the real thing. An Omniverse digital twin is a large-scale, physically accurate, I better talk into the mic, right? Simulation of an industrial asset, process, environment, any object, with multiple autonomous systems perfectly synchronized with real-world data streams. Now, what's the concept of the digital twin lies in the physical twin, or the origins of. In 1970, the Apollo 13 mission had a problem. The old Houston, we have a problem lexicon that has entered common use. A catastrophic failure, an explosion. There was an explosion of an oxygen tank, and it left the astronauts stranded far from Earth. So NASA used the physical twin, a replica of the Odyssey spacecraft, to troubleshoot and test the oxygen and electrical systems, and eventually they were able to get everyone back safely. But you can't always have a physical twin. Sometimes it's not possible. The construction is too large, it's too complex, it's not cost effective. So even up until today, while a lot of design work is computerized, a lot of funds, time and effort is consumed in building prototypes, for example. So like, for example, in airplane or vehicle construction. But if you could simulate the model or the concept in a digital world first, you could have a better understanding of what the finished product is going to look like, and what it should be. And you'd have far less need to make so many prototypes or design modifications after the fact, because you have a better idea in the physically correct digital world of Omniverse. I was interested to see the airplane virtual reality demo over there in the corner. In that example, for example, you could use, monitor the characteristics of the plane while in flight, while it's not really flying, it's on the ground. It makes it easier for the aircraft mechanics to understand how it might be behaving differently in the air. You could simulate all of that in a virtual environment of a plane flying through the air, right? So you could make modifications accordingly if it were a prototype. There are a multitude of examples like that across industries. So the applications of a digital twin are many. Instead of, for example, training robots in the real world, and creating a multitude of diverse situations for the robots to learn from, one could create a digital world that you can modify at will, to train robots in what we're terming robot gyms. The cute little soccer playing robots outside could use some training, I think, in how to handle a soccer ball, and that could be done in a virtual world. No disrespect to the people that made the robots, they're fantastic, but but you could perhaps gain insights into how better design the robot to begin with by playing with it in a digital twin in Omniverse. The top left example, that's an example of training robots. In the top middle, that's a cell tower and simulation of the signals. That's an actual example used by Ericsson. In the top right, that's you could train robots how to navigate a warehouse in a virtual world. That's an actual Amazon example, etc. And currently on the bottom left, Nvidia is working on a massive simulation of the entire Earth, the scope of which is going to be mainly for climate modeling, climate change, research, and weather prediction and natural disaster prediction. Finally, in the bottom right, for example, that's an example of autonomous vehicle training, where you could make a digital twin of roads. You can insert obstacles. Suddenly, a car, kangaroo. This is being done in Australia. A kangaroo jumping across the road. I don't fancy the idea. If we had to rely on physical twins, we're going to get Skippy and hit him with a car. That's not acceptable. And You know, these are the sorts of things and scenarios that we can model in Omniverse. So there are numerous other examples across a range of industries, such as healthcare. You know, I've seen a model of a human heart. It's not just a model, it's actually can beat as well. 3D models of COVID that have been generated in Omniverse. Climate, you know, there's tornado and hurricane simulations. Numerous construction examples, we just saw one. And for example, things like you could digital twin a mining plant, you know, and then simulate different conditions, different wear, so that you could plan your predictive maintenance better. So the possibilities and use cases are infinite. Okay, so one of the things you can do in Omniverse, for example, is simulate a whole digital twin of a factory. And this slide just basically depicts how leveraging the USD file format, we can have multiple designers plugged into it using different CAD products, okay, because a lot of designers are used to one or the other, all plugging into the digital twin, which then on the outside, on the right there, you can then leverage for lots of different things like robot learning, planning machine upgrades, safety, ergonomics, and all kinds of different purposes and outcomes. And BMW has done exactly this, leveraging Omniverse, by creating a virtual twin of their entire factory. I mean, accurate down to the millimeter, complete with people in it, you know, and we'll watch a video right now about it, and I just think it's remarkable because, you know, they've done a lot. Like, for example, monitoring workers' ergonomics, so robots come and deliver parts to the workers' station. How far is that person bending or twisting? If we position the toolbox here and the parts over there, can we gain, I don't know, better efficiencies because you have to walk around less? So in theory, you could fit, I don't know, 5 bolts a minute instead of 2. That leads to efficiencies at scale and whatnot. So let's go ahead and watch this video, which I think is pretty cool.
Welcome to BMW Production, Jensen. I'm pleased to show you why BMW sets the standards for innovation and flexibility. Our collaboration with Nvidia Omniverse and Nvidia Ai leads into a new era of digitalization of automobile production.
Fantastic to be with you, Milan. I'm excited to do this virtual factory visit with you.
We are inside the digital twin of BMW's assembly system, powered by Omniverse. For the first time, we are able to have our entire factory in simulation. Global teams can collaborate using different software packages like Revit, CATIA, or point clouds to design and plan the factory in real-time 3D. The capability to operate in a perfect simulation revolutionizes BMW's planning processes.
Are those gaskets still in the right place for you?
Yeah. BMW regularly reconfigures its factories to accommodate new vehicle launches. Here we see 2 planning experts located in different parts of the world, testing a new line design in Omniverse. One of them wormholes into an assembly simulation with a motion capture suit, records task movements, while the other expert adjusts the line design in real time. They work together to optimize the line as well as worker ergonomics and safety.
Can you tell how far I have to bend down there? So we'll get you a taller one, but there's... Yeah, that's perfect.
We would like to be able to do this at scale in simulation.
That's exactly why NVIDIA has digital human for simulation. Digital humans are trained with data from real associates. You could then use digital humans in simulation to test new workflows for worker ergonomics and efficiency. Now your factories employ 57,000 people that share workspace with many robots designed to make their jobs easier. Let's talk about them.
You're right, Jensen. Robots are crucial for a modern production system. With Nvidia Isaac Robotics platform, BMW is deploying a fleet of intelligent robots for logistics to improve the material flow in our production. This agility is necessary since we produce 2.5 million vehicles per year. 99% of them are custom.
Synthetic data generation and domain randomization available in Isaac are key to bootstrapping machine learning. Isaac Sim generates millions of synthetic images. and vary the environment to teach the robots. Domain randomization can generate an infinite permutation of photorealistic objects, textures, orientations, and lighting conditions. It is ideal for generating ground truth, whether for detection, segmentation, or depth perception. Let me show you an example of how we can combine it all to operate your factory. With NVIDIA's Fleet Command, your associates can securely orchestrate robots and other devices in the factory from mission control. They can monitor in real time complex manufacturing cells, update software over the air, launch robot missions, and teleoperate. When a robot needs a helping hand, an alert can be sent to mission control, and one of your associates can take control to help the robot. We're in the digital twin of one of your factories, but you have 30 others spread across 15 countries. The scale of BMW production is impressive, Milan.
Indeed, Jensen. The scale and complexity of our production network requires BMW to constantly innovate. I am happy about the tight collaboration between our two companies. Nvidia Omniverse and Nvidia Ai give us the chance to simulate all 31 factories in our production network. These new innovations will reduce the planning times, improve flexibility and precision, and at the end, produce 30% more efficient planning processes.
Milan, I could not be more proud of the innovations that our collaboration is bringing to the factories of the future. I appreciate you hosting me for a virtual visit of the digital twin of your BMW production. It is a work of art.
So I won't talk much more, but I thought we might watch another example, and then there's another video after that one at the end, and then we'll close. But let's watch another video, and this one is about Amazon's warehouse and how they've automated and have a digital twin of their warehouse factory in Omniverse.
Welcome to BMW production.
Every day, hundreds of Amazon facilities handle tens of millions of packages, with more than 2/3 of these customer orders handled by robots. To support this highly complex operation, we deployed hundreds of thousands of mobile drive robots and associated storage pods, which allow us to store far more inventory in our buildings than traditional shelving, and which help us move inventory in a safer, more efficient way. Key to the scaling has been our ability to simulate these buildings and understand their performance before we build them. Let's take a look at how NVIDIA Omniverse is helping us optimize and simplify these processes. At Amazon Robotics, we're able to create full-scale digital twins of our warehouses in NVIDIA Omniverse, helping us optimize warehouse design, train more intelligent robot assistants, and gain operational efficiencies. In Omniverse, we are uniquely able to aggregate data sets from many different CAD applications and visualize these massive models in full fidelity realism, enabled by Omniverse's RTX accelerated ray tracing, materials, and physics. Digital twins are an integral part of future warehouses and factories, enabling continuous integration and continuous delivery. With each new software and layout optimization, we can test in the digital twin before releasing to the physical warehouse, preventing any system downtime or failure while maximizing operational efficiencies. Next, packages of every shape, size, weight, and material move rapidly through our fulfillment centers. We use NVIDIA Omniverse to better train autonomous robotic sorting and picking solutions. Training these robots' perception systems accurately enough to prevent system failures requires massive amounts of high-quality data, but often the data doesn't exist or there isn't enough. When we introduced more reflective tape to our packing materials, the perception systems failed. We retrained the models with physically accurate photoreal synthetic data generated in Omniverse, indistinguishable from reality, saving weeks of retraining time and increasing model accuracy. Finally, with the digital twins of our facilities and the ability to quickly and accurately train robot perception systems, we can also better configure human-robot workstations, simulating opportunities for better employee ergonomics. At Amazon Robotics, NVIDIA Omniverse digital twins are helping us as we reimagine warehouse logistics from end to end, and capturing a significant operational efficiencies which enable us to deliver more value to our customers.
Cool. So we've seen how Omniverse is a design collaboration tool, but we've also seen how it's the engine in which you can create a digital twin to do many things. But one of those is to help you train AI with infinite number of different scenarios and situations. So see you in the Omniverse. You know, I can help provide more information. I can organize a free trial and other information. We're going to queue up one more video, and that goes for 3 or 4 minutes. It's by our, it's an excerpt of our CEO's keynote. We had every year, Nvidia has an event called GTC. It's become quite the AI technology conference, and his keynote is worth a watch. So if it's on YouTube, if you want to have a look, it's about 1 hour and 40 minutes, but it's pretty entertaining. And I like watching it every year. It gives us a massive amount of insight into what other goodies Nvidia's cooking up, and is a whole lot more other than just Omniverse. But let's queue up this video, and then we'll break for drinks, and I'll say goodbye.
The Apollo 13 crew was 136,000 miles from Earth when a faulty electrical wire caused one of the 2 oxygen tanks to explode. And the now infamous words radioed back to NASA.
Hey, Houston, we've had a problem here.
To work the problem, NASA engineers tested oxygen-preserving and power cycling procedures on a replica of the Odyssey spacecraft. Apollo 13 would have ended in disaster if not for the fully functional replica on Earth. This was an important moment. NASA realized the power of the replica, but not everything can have a physical twin. So NASA coined the term digital twin, a living virtual representation of something physical. Extended to vast scales, a digital twin is a virtual world that's connected to the physical world. And in the context of the internet, it is the next evolution. And that's what NVIDIA Omniverse is about. Digital twins, virtual worlds, and the next evolution of the internet. Over 20 years of NVIDIA graphics, physics, simulation, AI, and computing technologies made Omniverse possible. Simulating the world is the ultimate grand challenge. Omniverse is a simulation engine of virtual worlds. Omniverse worlds are physically accurate, obeying the laws of physics. Omniverse operates at vast scales, and Omniverse is shareable, connecting designers, viewers, AIs, and robots. But what are the applications of Omniverse? I will highlight several immediate use cases today. Remote collaboration of designers using different tools, sim-to-real gyms, where AI and robots learn, and industrial digital twins. But first, let me show you the technologies that make Omniverse possible.
Omniverse technology will transform the way you create.
occurred to me just now, am I still on? Yes, I am. It occurred to me just now that I probably should have just played that video and shut up and not talked at all, but hopefully that's given you a better insight. I want to thank RMIT for having me. I look forward to partnering together with RMIT on all things AI, and to all of you, thanks for coming.
So on that note, I think I don't need my enough. We're going to see we go from Omniverse to real world. Yes. We're going to have some real great sponsors that are next to Gary. Therefore, the sponsors are going to see ITS over there doesn't relate to the CEO. Thanks to demos, thanks to everybody. Find out what you guys have drinks.